Right. So tree data structure is something like this. Okay. So if someone asks what is a tree data structure, it's a hierarchical collection of nodes connected by edges. Okay. Hierarchical of collection of nodes, right? Connected by edges. Okay. And each node has 0 or more child nodes. So this node has 4 children. This node has 3 children. But these nodes, they don't have any children. Okay. And there's another important property, that is exactly one path from the root node to any other node. So if you take any other node and the root node, there must be only one path. Right? There must be only one path. In other words, you can't have cycles. You can't have cycles. Okay. So that is very important. So therefore, what are the key features? There can be only single root. Okay, it's hierarchical. The hierarchy means you can look at it as this level, something like the management structure, right? Strategic management, tactical management, and so on. So therefore, it's hierarchical. And there can be single root. You can't have more than one root if it is a tree. And no loops, right? So no loops means you can't have something like this. Okay, so then there's a loop. So then it is not a tree, it is a graph. Okay, it is a graph. Right, so that is what is mean by a tree data structure. Remember, we discussed about linked list. Linked list is a linear data structure. It's a linear data structure. But this is not non-linear data structure, because there can be another one. There can be another one. So there can be another one. Likewise, it grows like a tree. Okay. But only thing is, you can have only one root. You can't have something like this. So then these are not, these, or as a whole, it is not a tree. And also there can't be loop like this. Okay. There can't be loop like this. Right. Right. So these are the key concepts we want to understand. So let's take one by one. The root node. Every tree has a root node. Okay. Every tree has a root node, and only one root node. You can't have multiple root nodes. And that is a node having no parent. So every other node has a parent. You can see A is the parent of C. K is the parent of P. But there's only one node in the tree that doesn't have a parent, and parent node, that is called the root node. Okay. So it's very important that you precisely define something. Right? Precisely define something. I don't know whether you can remember when it comes to O-level also, usually they give sometimes one question, write down that particular theorem. So that is not to check whether you have memorized it. Can you write something precisely? So therefore, what is a root node? A node having no parent is called root node. And in a tree data structure, you can have only one such node. Okay. Right. So then edge or edges. So those nodes are connected using what is known as edges. So these are all edges. So every node is connected to another node using an edge. Okay. But some nodes have connected to multiple nodes as well, right? But you can have multiple parents, but you can have multiple children also. So, but node edge is connecting two nodes. So this is one edge, this is another edge. Okay, edge. So the next concept is parent nodes and child nodes. So predecessor of a node is called its parent. Predecessor, previous guy. For example, previous guy of B is A. So therefore, predecessor of B is A. So therefore, parent of B is A. And parent of C, D, and E are is also A. But if you take K, its parent is D. If you take Q, its parent is K. Now you can see these nodes are parent nodes of some nodes. Okay. But these nodes are not parent nodes because they don't have child nodes. These are not parent nodes. And other side, if you look at it from the other way, a descendant of a node is called its child nodes. For example, B, C, D, and E are descendant of A. So therefore, B, C, D, and E are children of A. Similarly, F, G, H, children of B. O is a children of H, and so on. Right? Child node. So we use these terms when we build some concepts. Okay. So then we have leaf nodes. So leaf nodes are nodes having no children. If a node has at least one child, it is not a leaf node. Okay. This one has 3 children. This one has 2 children. This one has 4 children. This one has 2 children. Okay. Right. So this must also be a leaf. Okay. So I will fix it, otherwise I will forget it. So because I am just working on this node. So this one is also a leaf node. Right. So that one is also a leaf node. Sorry for that. Okay. Right. So if a node is not a leaf, if a node is not a leaf node, we call it internal nodes. Right. So therefore, every node is either leaf node or internal node. So internal node means it has a child, at least one child. So every node is either leaf node or internal node. Okay. So this is also internal node because it has children. But you can see children nodes are, leaf nodes are not internal nodes. Right. Internal node. So let me take it to the previous one. Right. So then we have a concept called sibling nodes. So sibling nodes are sort of brothers and sisters. Of course, in nodes, there's no gender difference. So basically, we call them siblings. So these are all sibling nodes. It's a relative concept. C is a sibling of B, D, and E. K is a sibling of L and M. P is a sibling of Q. Q is a sibling of L. Now you can see that this node doesn't have a sibling. This one doesn't have a sibling. This one doesn't have a sibling. Of course, always the root cannot have a sibling because there can be only single root. And also, some nodes may not have siblings as well. Right? For example, if you take something like this, now this one also doesn't have a sibling. This one also doesn't have a sibling. Now, you can see even internal node may not have sibling. Right? Even internal nodes may not have siblings. Okay. So sibling means your parent has more than one child. Okay. Right. So that is called sibling nodes. So then we have another concept called degree of a node. So degree of a node is total number of children of a particular node. For example, A has 4 children. So therefore we say degree of A is 4. B has 3 children. So degree of B is 3. H has only one child, degree is 1. And obviously, the leaf node have degree of 0. That is why we call them leaf nodes. Right? That is why we call them leaf nodes. So you have to relate these concepts also. Now, leaf nodes has degree of 0. So that's a statement. Yes. Okay. Right. So the next concept is level or depth of a node. Right. Level or depth of a node. So depth is calculated from top. So we take root node is in level 0 or depth 0. Okay. So then the next level comes, that is the children of the root. Then their children are in the level 2 and so on. So level always, so the depths always start with 0, 1, 2, 3, etc. So that is called the depth of a node. Okay, depth of a node. So then we have height of a node. So that is so this is little bit tricky. Height. So height of a node is number of edges from leaf node to a particular node in the longest path. Okay. For example, this one from leaf, there's nothing, right? Therefore, the height is 0. But if you take this one, the height is 1. So therefore, don't think that it's like a level. No. Because from this leaf, it has to come 1. So therefore, this one's height is 1, whereas height of these two are 0. Right? So that is the difference between, now depth is different because all these nodes have the same depth. Right? All these nodes have the same depth. Okay. But height is not like that. Height is not like that. Though they are in the same depth, they can have different heights. For example, these are in the same depth, but this one's height is 0, this one height is 0, but this one height is 1. And if you had another one like this one's height is 2. Okay. So you have to take the longest path. So therefore, what is the height of this one? You have to take the longest path, that is this, that to this. So then 1, 2, 3. Okay, 3. So that is called height of a node. Right. For the rest of the stuff, I will be referring to the old node because I have not prepared the rest of the stuff yet. Right. So that is called height. Okay. Right. So we have discussed these things. Right. So then we have another word called ancestors. Okay. Ancestors. Ancestors can mutumito. So that means, for example, ancestors of FG and D are A. Right. Because its parents, usually you don't take parent as ancestor. Sometimes you can take parents also as ancestor. But ancestors means even higher level or parent to higher level. Right? So any node. So if you have something like this, now if you take this node, its ancestors include this one, and this one, but not the others. Okay, not the others. That is another concept, ancestor. Or in the other side, we can say descendants as well. Okay, Darumunu Puran. Right, so we discussed the degree, level, height and depth. Right, so then we have what is known as subtree. Right, subtree. So let me refer to this tutorial because I'm taking a lot of stuff from that one. Right. So right, subtree is something like this. So this is a subtree. This is a subtree of the main tree. And this is also a subtree. It's a subtree of the big main tree as well as subtree of this tree. So therefore, subtree can be a subtree of more than one tree. Okay, more than one tree. So that is called a subtree. Okay. Right. So then we have path. So path is you start from one place to go to another place. Okay. So then we call it path between those two nodes. For example, so from here to here, it's a path. Or from root to here, it's a path. Okay, that is called path. Okay. Right. So then forest is collection of trees. Say you have maybe related, okay? Something like this. And again, you have another something like this. But as a whole, this is not a tree. But this is a tree, this is a tree, maybe we have another tree. And collection of these trees, we can call it a forest. Right? They are disjoint trees. But individually, those are trees. But collectively, it is not a tree. So then we call it a forest. Okay. Right. So traversing and visiting we'll look at later. Right. So then there are two types of trees. The first type of tree is called binary tree. If it is not a binary tree, we just call it a tree. Okay. So therefore, binary tree is a special case of a tree. Right. So this is a binary tree. Binary tree means a tree where degree of each node is 2 or less. You can't have more than 2. Degree means how many children. Right? If you have at least one node having more than one child, it is not a binary tree. You can have maximum 2 children, maybe 1 children, or no children. That is fine. But you can't have more than 2 children. And of course, it must have single root. That is why we call it a tree. If it does not belong to that definition, it's a general tree. But still, it has to comply with the definition of tree. That is hierarchical, single root, okay, one parent, no loops. Then it's a tree. But to make it a binary tree, we have to make sure that no node has degree more than 2. Okay, so then we call it a binary tree. Right, from this point onwards, our discussion is 100% on binary trees, nothing else. Okay, so at the very end only, we will look at a little bit about the non-binary or the general trees. Okay, general trees. Right, so when you take a particular node, of course, if it is a binary tree or not, you have a left subtree and right subtree. Every node has a left subtree, right subtree. Okay. Right. So now we look at a special case of binary tree. Actually, we are going to look at 2 special case of binary trees. One special case of binary tree is called binary search tree or sorted binary tree. The other special case of binary tree is called binary heap. And there's a special case of binary search tree called balanced binary search tree. So therefore, actually, this must come somewhere here. Okay. Balanced binary search tree. So first we will look at binary search tree. Let me open the PDF note. Right. So first we will look at binary search tree and its special case called balanced binary search tree. And then we'll look at the binary heap. Okay. So today, actually, we want to look at only binary search trees and balanced binary search trees if you have time. Right. So what is mean by binary search tree or sorted binary tree? Remember, now we are talking about binary trees only. A binary search tree or the sorted binary tree is a binary tree where for every node, its left children are always less than it, and its right children values are always bigger than that. So if you take any node, something like this, its left children must have value smaller than its value. You can see 1 less. Right children 4 and 3 both are bigger than 2. It must be true for each and every node. If you take 4, its left child is less than 4, yes, no right child, that is fine. If you take this one, no left child, but if you take all these right childs, they are bigger than 6. So this has to be, now if you take 5, all its left childs are less than 5, all its right children are bigger than 5. So this must happen to each and every node. That is how you define it. So therefore, in general, you will see that it's basically sorted from left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then someone will ask, okay, can't we say that 3 is somewhere here? No, because your 4 is coming from right of 2. So therefore, though you draw it like that, this node is always left of 2 because its parent is right of, this must be always right of 2 because its parent is right of 2. Okay, so sometimes when we draw it, it might go there beyond this one because we are running out of space, but that is how you interpret. So therefore, it is always sorted from left to right. But how do you write the definition? Because it's sorted from left to right is, for human, it makes sense. But for computer, because we want to program this, model it in the computer, so we need a little bit better, precise definition. That definition is, if you take every node, each node, all its left children must be less than that. All its right children must be bigger than that node. So then it create a binary search tree. So we can, why do we call it? Of course, you can understand why we call it sorted binary tree, because it's sorted from left to right. So then why do we call it binary search tree? Because we can use this particular tree structure to do searching fast. Do searching fast. Therefore, sometimes we call this binary search tree. Okay. Right. So it can be anything, right? It maybe those are letters, right? A, K, N, P, R. Maybe sorted in this way. Okay. Maybe numbers sorted this way. Whatever the way, it must be sorted. Maybe numbers, words, some concepts. Okay. Right. So now let's see how to create a binary tree, binary search tree. So of course, the first element will always be the root. Okay, the first element you add to the tree is always the root node. So then when you add another node, you check whether is it less than the root node, then it must go into the left side. If it is bigger than the root node value, you have to go right side. So if you go to the left side, then again you have to check with that one. Is it smaller than this one or bigger than this one? Maybe it is bigger than this one. Then again you have to check whether is my new value less than this or more than this. If it is less than this, of course it will be a left child of this. That means you don't, that child, if that node doesn't have a leaf, you can be the leaf or you can be the child. If it has a child, again you have to go there and check it and so on. So always you have to be a leaf every time you add a node, new node, it must be leaf at that time. Because you become a leaf of your parent. Maybe your parent already having right node, that is okay. If this node doesn't have a left node, and if you are smaller than that, you must be the left node. So try to understand this logic, then code it. So that is expectation. Actually, what I supposed to do today is explain these concepts and ask you to take your computer, Java or whatever, spend good 4 hours and model this. That is ideally how this should be happen, but because we are having only one day class per week, so it's unfortunate that I have to show you some coding and so on. But ideally, I should have explained this last time and give you 1 week to code it. Okay. Right. So one of the advantage of binary search tree is, of course, that is why we call it binary search tree. It's very fast to search something because it grows not linearly, right? In 2 dimensions, you can easily search something very quick. Okay, very quick. So that is idea behind binary search anyway. Okay. So we will look at the searching and sorting algorithms later. But before going to that, first you have to understand this. But don't think that it is only the searching that we need the binary trees. There are so many other usages as well. Okay. And also inserting and deleting is also fairly fast because you just go to few levels and you find a leaf to insert. Right. Delete is also, because searching is fast, obviously delete is also fast. Right. So now our task is implementing a binary search tree. Okay. Binary search tree. Now the difference is this is somewhat similar to linked list. So if you have already done the linked list coding by yourself, so now you are in a very good position to code this. Remember, we had a node. We keep the data part, node, say object, data. So then we had a link. Okay, we call it next. And it is of a type node, and we just call it next. So that means it can refer to another node. I told you it's a recursive association. Right? One-to-one recursive association. So that is why the node class has an instance variable, which is again type of node. So that is linked list. Now the only difference here is in tree, every node is referring to 2 other nodes. If you draw it like this, because we are familiar with the linked list. So this one is referring to 2 other nodes. This one may be referring to 2 other nodes, maximum 2 other nodes. There can be, it's not referring to anything at all, but maximum 2 other nodes. Okay. Something like this. So therefore it grow not linearly. Therefore, this is our first non-linear data structure. So modeling, understanding non-linear things are a little bit difficult than challenging than linear data structures. So stack, queue, linked list, those are linear data structures. Of course, hash is a special data structure. It's neither linear nor non-linear. But this is our first non-linear data structure because it grows in 2 dimensions. Now you can think of how to model it. Again, we need to model a node. Only thing is, of course, the node has a data component. Let's call it object. But now a node has to look at maximum 2 other nodes because this is binary search, binary tree. So every node has to look at maximum 2 nodes. Of course, that node reference can be null. So that means that child is not there. Oh, it has both the children are not there. That is a leaf. But you need to have two instance variables of same type maximum. Sometimes for a particular object, it will be null, both null or one is null, or sometimes both are not null. That is what we have to do, as simple as that. So therefore, it's not a big thing. Okay. So we need to have a node class. Okay, rather than int, let's use object. So then we need two other instance variables. We can call them just the left child and right child, because remember, trees are hierarchical. So therefore, we can call just the children, left child, right child. And that's it, okay? So let's straight away do it. So when it comes to tree, they ask only, if it is code level, they ask very simple thing like how to model the node class. Actually, that's all they have asked. They have not even asked for you to write code on insert, delete. Right? But they can ask how to insert. Still, they haven't asked, I think. Most of the time, they are in the examiner is in the conceptual level, because the examiner I think examiner thinks that this is a little bit too much for a student to go in the exam, go and write the code, because you have very limited time. Okay. But they ask code for the linked list, stack, and queue. So let's call this our node class. So let's have a type object for our data, because we want to make it a general data structure. Call it data. And remember, we can refer to itself, same type instance. Let's call it left child, right child. Right, that's it. Of course, if you want, you can have constructor, so that we can use the constructor rather than setting the data later. Say object data. So this dot data, because I use the same name, equal data. Right, that's it. That's it, the node class. Now, in linked list also, we create a node class. Then we have to model the linked list, the insert method, delete method, and so on. So the real challenge is not modeling this one. This is, of course, when someone explain you, you can clearly understand. So now let's create the binary search tree class. So remember, now you have to compare this with linked list. In linked list, we kept one instance variable, that is the head. If it is double link click or doubly link list, we keep two nodes, left head or the head and the child. Sorry, head and the tail. Head and the tail. But single linked list, we keep track of only head. Remember, binary trees are like single linked list, because you don't go from, usually we don't go from leaf to the head or the root. We always start from root and go down the levels to the leaves. So therefore, we don't need double node. So that is why we just create a node as a normal node, not double node. But every node have two children now. So just compare. There's a difference between double node and a node for a tree. In double node also we had two, but that is your not child, right? Not child. It's you are referring to previous and next. Previous and next is, now you can see this class structure is the same as double link node or doubly linked node. because there also we had two nodes. We call them left and or previous and next. But this one is, though this class is pretty much the same, the overall data structure is different because the way we implement binary search tree insert is different. So likewise, you have to compare. Okay, so therefore what we need, we keep track of only the root node because that is where our starting point. Just like in the single linked list, our starting point is head. So therefore, let's have that also. So it's a type of node and let's call it root. Now we have to implement the insert method. Right, let's say void, return void. And again, this is like linked list. As long as you have the memory in the computer, running computer, you must be able to insert. And your tree will keep growing. Because we don't implement it using array. Okay. Right. So then when you insert, you have to give the data. So let's use object. So what is the first thing we want to do? We want to create a node because every time you insert something to the binary search tree, a new node is added. So therefore, let's do it. So this is just go by common sense. Okay, so let's say node n equal new node. Remember, we had a constructor, so let the constructor set the value. Right now, what we have to do? Remember, we keep track of root node. If root node is null, obviously this is the first node. So therefore, this one must be the root node. So that is common sense. So therefore, you can write that code because it's a special case. Okay, it's a special case. And you are done. So let's implement the special case first. Right. If actually you should have, I must have given you at least 1 week to think, code this by you alone. But unfortunately, I forget to do the theory part last time. Okay. Right. So if your root is null, then you are the root. So this one is the root. This newly created node is the root. So therefore, I can say n is root, or sorry, root is n. Now root get a object reference. Okay, and that is this newly created root. So you must be really strong about your object-oriented programming. What is a class? What is an instance? What is an instance variable? What is a class variable? I told you in the semester 1 when we did the object-oriented programming, I told you these 2 days are the most important days in your BIT degree. Most important sessions. Right? I kept it maybe many times. I told it many times. Because you can see that. So all these things depends on your confidence about object-oriented. That is why I did another revision at the beginning of semester 3 on object-oriented. Okay. Otherwise, you just blindly going here and there. Right. So now that is the very special case. Now we have to go into the general case. Okay. Right. So before moving to the general case, so let's try to build a root binary tree by ourselves. Okay. So let's assume this is my first node. Right. Say I just want to insert these data into a binary search tree. So these are my data. Say 40, 80, 20, 60, 30, 10, 70, 90. Okay, so first of all, before coding, you must know how the search tree is growing, binary search tree. So remember, the first element is always the node. So that is what we code also. So therefore 40 is in the root. First element is the root. Now 80. Now what you have to do? Remember the definition of binary search tree is every node, its left children must be less than that. Right children must be having bigger than the value. So therefore 80 is bigger than 40. So therefore you have to, because 40 has no right child, 80 must be the right child now. If currently, if there's no right child, and if this is bigger, that value must be the right child. So this is growing naturally. We just take one at a time. We assume you don't have any visibility about the others. Okay, it's growth like that. It's like a newborn child for a family. So that child has no idea about who are the future children in that family. Okay, right. So now 20. Again, you have to start with root. Now, of course, the root is there. Therefore, 20 can't be the root. Now, 20 is less than 40. So, therefore, it must be the left child because 40 has no left child. Now, 60. 60 is bigger than 40. So, therefore, you go to the right-hand side and check again. 60 is smaller than 80. So, therefore, it must be the left child of 80. These are done. 30. You have to start with root because we keep track of only the root. So 30 is less than 40. Therefore, you have to go left. Then again, you have to compare. 30 is bigger than 20. So therefore, you must be the right child of that. Then 10. You have to go to the root. 10 is less than 40. Again, you have to check. 10 is less than 20. So therefore, there's no left child. So therefore, 10 must be the left child. 70 bigger than 40. Lesser than 80. Bigger than 60. Right child. 90 bigger than 40, bigger than 80, right child. That's it. Okay. And now if you look at this, after inserting this, if you look at this, you will see that it is sorted from this 10, 20, 30, 40, 60, 70, 80, 90. Okay. That is, once you do that, that happens. Okay. But initially you will have no idea what is going to happen. You just follow the rule or the definition of a binary search tree. Keep inserting. And now can you write it as a code? What you're supposed to do? You look at your root. If it is not null, of course, you are done. That is your root. And now you have to write the else part. Now what you have to do? Actually, ideally, I should give you time. Okay, now it's good time for take a break also. Right. So I'll give 10 minutes break, 5 minutes for you to write the code. Okay, you to write the code. So write the code in the else part, your logic, and at the end you must have added the node, the new node to the correct as the correct child of the relevant node. Right. So that you have to write the else part. Right. So we'll start at it's say 8:10. We'll be starting at 9:05. You have 8 minutes for writing the code, 10 minutes for break. Right. Now, okay, so let's continue. Right, I hope at least you give it a try. Okay, because you can learn from some every code you write, you can learn something from that. Okay, because when you go into the final year, okay, forget about your career, right? You just want to get the degree. Let's assume like that, right? But when you go into the final year, so those category also struggle because you have to develop a system. If you can't build a logic, how can you build a system? Because now these days the final year students, so they start doing their final year project. So the most of the students, when they talk to us, right? So I can see that they are not very lacking confidence, right? Unfortunate, right? So when you go to the final year, you sit back and start doing your project, right? You can get the help of your fellow friends. You can talk to the supervisor, but no one is going to code for you, right? So your project is your project. So when you go to the final year, you must have that confidence. You don't think that when you go to the final year, by a magic or supernatural power, you get that power of coding. No, that doesn't happen. So now you can decide whether it's happening or not. Are you going to be in trouble when you're in the final year or not? Right? Because now you must get the feeling of your confidence, okay? Whether if you are doing it properly. Right. So what we have to do, we have to start with the root node. Of course, if it is null, we just make it the root. Else, right? Else we have to go. Of course, you can develop it in slightly different way. Sometimes at first it doesn't work. You have to write a test code. Remember the test-driven programming. Test-driven programming means first write the unit test, then write the code. Of course, first your unit test failed, but once your code is properly done, the unit test passed. So therefore, let's write a test case. Test first. I'll call it binary search tree test. So this, I have the main method. First, I will create a binary search tree instance. I call it binary search tree. New binary search tree. Right. So now I must be able to keep adding data. So what was the first data we use? 40. Okay. We'll do the same example. 40. Say BST dot insert 40. So then next one BST dot insert. What was our second one? 40, 80, 20. Okay, let me write everything. 40, 80, 20, 60, 30, 10, 70, and 90. Still, we have not implemented the insert method, but we have written the test code. Okay, of course. Right. So now let's get back to the implementation. Right. So what we have to do, remember, you have to start with the root. If the root is null, you make it root. Otherwise, you have to compare whether, say, I want to add something like, say, 55. Of course, the root is not null. So now you have to compare whether 55, you have to compare 55 with, this is the new value, with the current value. The root, the current value must be the root. That is where we start. So if my value is smaller, I have to go to the left. If the new value is bigger, I have to go to the right. So then again compare. Yes, my value is bigger. I have to go to the right. Again compare. My value is bigger. Again go to the right. But there's no right child. If there's no right child, this must be the right child of that node. So therefore, first I start here, then I go there, then I go there. So let's call it current. Current, we have to go either left or right, depending on the comparison. Okay, because we have done the linked list, now you must be able to write this code. That is why I asked you to take 10 minutes or at least 5 to 8 minutes and code it. First, you think about the solution. So then you have to transfer that solution into the code. Now, what is your strategy? You again say something like current, because now you have the experience doing this kind of a thing used in the linked list. Say it's a node type. Let's call it current, because that is a convention we use. And we'll initialize it to root, because we have to start with root. We did the similar thing in single linked list. We initialize it with head. Now you have to keep doing this until your current is, your currents next is, or left child or right child, depending on which one you are looking at, is null. If it is null, if you are looking for the right child, if the right child is null, your new node must be the current right child. If you are looking at the left child and the left child is null, your new node left child must be your new that current left child must be the new node, right? So you have to do it in a loop. So what is that loop? While current is not equal to null, or you can write whatever the way you want, but this is how I go. Maybe I will change it if I feel something's easier. You have to now do the comparison, and you have to move your current to the left or right. And when your current is null, that means you have to stop and do the add the new node to the left or right, depending on. So now, of course, I'm not asking you to use the exact same thing. Maybe you can use slightly different thing, but I just gave you the structure for the answer, your code. Now I will give you another 5 minutes for you to do the coding. Right. Take another 5 minutes and see whether you can do it by yourself. I'll give another 5 minutes, because this is a practical subject. Okay, no point me writing the code. Right. Now, of course, if you want, you can use a different structure, but don't look at the code in the note, right? And see whether it's working, and then you can run it. Of course, still you can't see, but you can do a debug and go there and see whether it's properly done. Okay, forget about the testing, just write your code. I'll give another 5 minutes, okay? Because you have to write it, not me. Because in the final year, you have to write the project, develop the project, not someone else. So this is where you get that experience. The starting point is here. Start writing some code, some serious code. Because remember, this is a professional degree program, right? So engineers, doctors, businessmen, they are serious people. So they're doers. They're doing things. They see the success. Of course, if not, don't do IT. Do something else. Now, if you do this like this way, there's a small issue. That is, when current is null, right? How do you add it? So therefore, there's another approach to do this also. That is, you do that and you break your loop. So then you can start with while true. I think that will be easier. That will be easier. Okay. While true, that means you are going in a never-ending loop. But once you get your left child or right child is null, you do the stuff. Vede kara break puna. Vede kara kapuna. I think that will be easier. Because otherwise you get into that chicken egg story. When you have that correct place, now you are in null. Okay. Think about it. I think this approach is easier. Or you can use the other approach. Maybe then you have to take the previous. Just behind you. Okay. Because we don't do the coding for delete and other things. We do coding only for this method. We don't do any more coding for trees. So that is why I'm giving you time. It doesn't mean that we can't do the delete method and so on, because when you are doing the node deletion, there are different scenarios. So you have to write your code must tackle scenario 1, scenario 2. That is why they don't ask. Okay, because it's a lengthy code. But insert is straightforward code. If you can't write the insert method, so that means you are not up to the standard. Okay. You are not ready for your final year project. Unfortunate. Right. So this is my solution that I tried. Of course, I'm also now writing fresh. Of course, I have written this many times, but now I'm again freshly thinking because I don't memorize things. I have better things in the world. Okay. Right. So this is what I do. If now remember current is root because current is not null. I know that current is not null because that is why I'm in the else. Okay. If if data is greater than current dot current data, current data. So that means what? I have to go to the, okay, that is because it's object, right? It's object. Now remember, now if it is object, we have to define how do we compare things. Okay, how do we compare things? So in order to do that, what we do is there's a method called compare that you have to override, right? That you have to override. Since we are not going to do that, let's assume this is an integer. Now, those are the practical things you have to think. How can I compare objects? So if maybe you should have asked that question during that 5 minutes, or you should have searched that problem. How can compare objects? Okay. I think we had the same problem when we do the linked list. So what was the approach we took? I think we took a simple approach there. Let's look at the code. Because maybe that problem you have already solved. That is what experience is. Okay. Yes, we had that problem earlier also. What was the solution we took? Comparing. Same 3. We didn't do the sorted linked list, right? We did only we didn't do the sorted linked list. So therefore, we didn't have that problem. Yeah, this is the first time we have that problem. Because now it is sorted. Right, so there are few solutions. Okay, so you can do a Google search now. Okay, of course, I also do Google search. Or else I will change this to integer rather than object, integer. Because how do you compare integer is different from how do you compare string? How do you compare char? Because it depends. Okay, so therefore, though we just call it data, right? So though we call it's a general data structure where anything can be your data, but when it comes to comparison, that anything we can't compare, right? Now, can someone give me a solution for this? Now, remember, last time we discussed about, now this is a very serious discussion. Now, this is not semester 1, neither. Lossinger talk now. Okay, so now you have learned about polymorphism, inheritance, frameworks, right? Libraries. This is a serious stuff. Degree level stuff. Okay. Can you come up with a solution for this problem? Right. So this is more important than your data structure. Possible way to address this kind of a problem in real world software development, because if at least some of you guys become software developers in the future, you will face these kind of scenarios. An architect will say, this is how you solve this kind of issues, or he will say, this is one approach, this is another approach. So your task is get that experience quickly, right? Just think by yourself rather than changing this to narrow it to integer or whatever. One possible way of solving this kind of a problem. Anyone? Or maybe you have already tried this, face this kind of issue, and maybe you have already searched, or you can do the search right now and tell me one possible way of solving this kind of problem. Or just now you can do the search, Google search. I will give you another 3 minutes. You can search, of course. No one is born with all the knowledge in the world. So that is why we learn from each other. We Google search and those things are there. Right? What can be the possible solution? No, that means we are again restricting to integer, because now remember the idea behind making these objectives, let users use it as a general binary tree. Let them insert integers, let them insert double, let them insert character, let them insert strings, or let them insert some objects which has a meaning for what is bigger, what is smaller. Right? What is bigger, what is smaller. For example, you might say February is bigger than January. Maybe that guy is keeping months, the month of a date of birth of students. So then you must know that, of course, March is bigger than February. So therefore, we want to make this general data structure. General data structure. Do a Google search. Right? Do a Google search right now and tell me what you find. Then I will also do a Google search because I know a possible solution, but I can't remember exact coding. But I know that one approach of solving this kind of problem, because I have been working as software developer for more than 10 years with that experience, of course, because these kind of problems are day to day we encounter when you go to work. So that is why they are paying us high salaries. This is our bread and butter, solving problems. Maybe you are working in an accounting project, maybe you are working in airline reservation, sorting, searching. Anyone got an answer? Just see whether how good you are in doing a Google search. Because remember, doing a Google search is also a skill for modern humans. පොඩි කාලේ උගන්වන්නේ දෑත වැඩ කියලා නේද? ඇඳුම් මහ ගන්න ඕන මම කියන්නේ කියන්නේ ඇඳුම් මහ ගන්න එපා කියලා. හරි? ඊළඟට අපිට මට මතකයි අපි එකන් යනවා පාත්ති කොටනවා අපි. හරි? නමුත් මගේ ජීවිතේ මම තවදුරටත් පාත්ති කොටන්නෙත් නැහැ ඇඳුම් මහන්නෙත් නැහැ. මට හැමදාම ඕන වෙන්නේ Google search එකක් කරගන්න වගේ දේවල්. ඔන්ලයින් පේමන්ට් එකක් කරන්න. ඔය තමයි මගේ ජීවිතේ මට ඕන එදිනෙදා දෑත වැඩ ටික. එතකොට අධ්‍යාපනය වෙනස් වෙන්න ඕන. සිංගප්පූරුවේ ඉන්න මිනිස්සු පාත්තිවල බගා කරන්නේ නැහනේ. අයිස්ලන්තේ ඉන්න මිනිස්සු බගා කර ඉන්නේ නැහැ. මම බගා කරන්න එපා කියන එක නෙමෙයි. අපි ඉගෙන ගන්න ඕන අපිට නිතර ඕන වෙන්නේ. එදිනෙදා ඕන වෙන්නේ. මට එදිනෙදා ඕන වෙන වැඩිම අවශ්‍ය දෙයක් තමයි සර්ච් කරන්නේ. අයින අපි ඕක ඉගෙනගෙන ඉන්න ඕනේ ඉස්සෙල්ලා. Right. So my problem is I keep it as object because objects are polymorphic. Okay, that is why we keep object. Object can be anything. But how can we compare the anything? So I am the one who write this code. Right, I am the one who write this code. How can I write a comparison which is applicable for anything? It's like a magic where whatever you add, our comparison work. Our comparison work. It doesn't matter whether it's numbers or letters, because for example, now I can add 40. Not only that, I can add something like this. I can add single quote A. Right? You can see that is why we make it object. Some students don't know why we make it object, because anything is object. Because, right, for example, if I have a I assume that I have a class called, of course, the error is because I have not finished the code, right? So say I have a class called, say, dog. Now I should be able to even add dogs to this binary search tree. Say dog, D equal new dog, and binary search tree, insert my D. Okay. That is the idea behind making that object. Sometimes you just make it object, but you don't know why. Now my question is, how do we compare? If those are dogs, if those are strings, if those are characters, if those are accounts, how do we compare? Because now we have to do a comparison. Okay, I will undo it. But let's assume user is only sending one type, because user is not crazy, right? If something has to be comparable, Everything must be of the comparable things, compatible things. We can't compare mango with tomato, tomato with orange. Anyone? So actually you can come up with two solutions from your semester 1 knowledge. So a lot of students take semester 1 programming very lightly because most of the students have no objectives in their life. Unfortunately. That is why නේද ඊට පස්සේ රැකියා විරහිත උපාධාරීන් කියලා පාරවල් දිගේ යනවා කාලකන්ණි හැද්ද. ජීවිතේ ඔබ්ජෙක්ටිව් එකක් නැහැ. අපි ඉගෙන ගත්තේ කාලකන්ණියෙක් නොවෙන්න. එච්චරයි. අම්මලාට තාත්තලාට බරක් නොවෙන්න, රටේ ඉන්න අනිත් මිනිස්සුන්ට බරක් නොවෙන්න තමයි අපි ඉගෙන ගත්තේ. අපේ ඔබ්ජෙක්ටිව් උනේ කාලකන්ණියෙන් නොවෙන එක. එච්චරයි. කායෙන් හරි යැපෙන්නේ නැතුව ජීවත් වෙන එක. ඒ වෙනුවෙන් අපි වැඩ කරා. ඉගෙන ගත්තා. අපිට ඉස්සෙල්ලා ආවේ ඔබ්ජෙක්ටිව් එක. උපාධි ගන්න එකවත් නේද ෆොටෝ ගහ ගන්න එකවත් බිත්තියේ එල්ලලා තියෙන එකවත් නේ අපිට ඉස්සෙල්ලාම ඕනේ අම්මලාට තාත්තලාට අපේ බර නිදාස් කරලා දෙන්න. ඊට පස්සේ රටේ අනිත් මිනිස්සුන්ට බර නිදාස් කරලා දෙන්න. අපේ බර ඒගොල්ලෝ අදින්න එපා. ඕගොල්ලෝ ඩුබායි ගිහිල්ලා අපේ බර අදින්න එපා. Right, how do you do that? ඕගොල්ලෝ එකක් කියන එක. So one sub topic you learn is generics. Right, generics. So you can introduce, you can let the users decide the data type. So that is one thing. So you can say something like X or something like. So then you make this type X. Right, in one solution. So then user decide what is this type. Right, but that solution will not work here. Oh yeah, we can make it that work here also, but that is one solution. Right? Let the user decide whether you are going to add orange or papaya or mango or whatever. But once you say mango, you must keep adding mango. Okay, keep adding mango. So that is one solution. I will not go for that solution. The second solution is, remember what is the idea behind framework? අපි framework ගැන එදා කතා කරන්නේ. So what is the difference between library and framework? The framework පාවිච්චි කරලා finally project එක කරන කට්ටිය framework පාවිච්චි කරන අය කරන්නේ. සමහර framework එකක් කියන්නේ මෙලෝ අලබෝලයක් දන්නේ නැහැ framework එකක් කියන්නේ මොකද්ද කියලා. framework පාවිච්චි කරලා software develop කරන්න පටන් ගන්නවා. අර ඊට අයත් නොදන්නී අය යන මාවත වගේ තමයි framework එක දන්නේ නැහැ. මේක කියන්නේ මේක දන්නේ නැහැ. framework කියන්නේ අපි දෙන්න එකතු වෙලා framework එක software develop කරනවා. framework පාවිච්චි කරලා. So what is the idea behind framework? Anyone? Because we discussed about frameworks in web development last week or 1 week before. In framework එකක් කියන්නේ මොකක්ද කියලා හරියට කියන්න බැරි නම් framework use කරන්න එපා. ඔයා අමාරු වෙනවා. So what is the difference between library and framework? Anyone? What is the difference between, for example, you can use a library to send an email, logging. But you can use something like Laravel as MVC framework, struts as MVC framework. It's not a library. Even something like Bootstrap is sort of a framework. What is the difference between library and framework? So library we call and it does the work and give. So that means you are in control. You are in control. Right? You just call it. කාටරි කියලා help එකක් ගන්න ඊට පස්සේ ආ ඊළඟට වැඩේ කරනවා. help එක දුන්නා ඉවරයි. But in framework is in control. So you have to write the code according to the expectation of the framework because framework determines the architecture. Right? Framework determines the architecture, which is good because we are giving that control to the framework because otherwise we have to write that logic. So if someone do it, we say, okay, yes, you do it. I will do it. I will do my part according to your expected way. So that is why when you're using framework, you must be really disciplined. Because otherwise, all of a sudden, it doesn't work and you have no clue about that. That is, if you don't know about how the framework works. Now here also, we can use similar approach. Right? Similar approach. That is, you decide. So yes, you are using our binary search tree. And binary search tree, we will implement how the binary search tree work, how the insert happens, how the delete is done, how the search is done. Let us do it. Let me do it. But you have to help me. That is, I don't know what kind of things you're adding. Alada Bombay lunuda neda. අපි දන්නේ නැහැ. ඔයා ලියන්න ඕන compare කරන විදිය. So you write how to compare. Right? So then you use binary search tree, but whenever I need to compare something, I will again call you and again I will take the control. So that is what polymorphism. Right? So you don't have to come and change my binary search tree or the binary search tree class or the node class. Right? But it will work. In the future, maybe you want to add tomatoes, potatoes, chili, or whatever. You don't have to each time come and change our code, but only thing is you have to change or you have to write how to compare, because I rely on your comparison logic, because I don't know what kind of things you are going to add in the future. So that is what polymorphism. So where is the reusable code? This is reusable because you don't have to come and change here. Because we have written it in a polymorphic manner. But when we write it in a polymorphic manner, at the same time, you have to do little bit of things. So because we rely on your task. Yes, we are in control, but time to time, we call your code and again come back to us. So that is what polymorphism is. So that is what we did it in semester 1 event handling. So you are calling the action listener and everything is there, already written. Action listener, item listener, but you have to write the action perform method because your JDK doesn't know what to do. But overall event handling is done by JDK, Java. But exactly what to do, it has no idea, right? So therefore you have to write exactly what to do in your code. So then your JDK is in control, but time to time we call your code and see what you have written there. So that is done, and then again JDK take the control. So that is also a framework within the JDK, right? Event handling framework. So we call it swing is a event handling framework. ඉතින් මේක නොතේරෙන සාකල් වල software develop කරන්න බෑ. හරි? කවදා හරි මේක තේරුම් ගත්ත දවසට ඔන්න එදා ඉඳලා තනියෙන් software develop කරන්න පටන් ගන්නවා. So you have to spend time on not memorizing things, but understanding the concepts. Okay. So that is what we lack in our education system also. හරිනම් ඔය concept නොතේරෙන අය ඊළඟ level එකට යන්න බැරි වෙන විදිහට paper එක හදන්න. අපි හදුවා නම් මේ paper එක ඒ විදිහටම හදනවා. හරි? අර යාගේ හක්කේ දත් කීයක් තියෙනවද? මෙයාගේ බොක්කේ මොනවද තියෙන්නේ කියලා අහන්න නැතුව. ඕවා කටපාඩම් කරන් කියලා ලියන්න පුළුවන්. Right. So that is the second approach. Okay. Now let's do the Google search. How to compare objects. Because that is why we use object, right? How to compare objects in Java. So that is the equal method, right? Okay. How to not compare, search, sort. Is it sort? Yeah. You can see. Create order object as a custom or whatever. Implement comparable and comparator interface to define the sorting logic. So that is one solution. Okay. Even you can do it in collection framework. Okay. So you have comparator and comparable interfaces. That is one option. Okay. Say you want to sort array. So this is even simple example, right? You want to sort array, but how do you know how to sort an array like this? Maybe, okay. Of course, this is sorted by alphabetical order. First character, second character, right? If you have A and A and AB must come after A. Okay. So this is another way where you sort it using comparable interface. So then let the user decide how to compare, how to do the compare. We just say you have to implement that interface. Okay, we just say you have to implement that interface. Okay, so this one is not very good example. Yeah, you can see comparator. Of course, it is used in so many, even generics are used, right? But you don't have to always use the generics. Okay, so you can see sort objects with comparator. Okay, so what you can do is let the user decide how to compare. So then we call that compare method. Okay, we call that compare method. So I will give it as an exercise, right? I will give it as exercise, but today I will implement it for integers, right? So I will give you 1 week to modify that code and change it so that let user do the comparison, but you just call the user's particular method. Okay, it's something like you defer that to the user. That means you make it like your binary search tree is like a framework. Okay, binary search tree is like a framework. So let's go to the object class and see whether it has a compare method. Then it is even easier. So this is native hash code. You can see equals is there, but not compare, right? If you have compare, no. You can see the equal method is there. Unfortunately, object doesn't have a compare method. Okay, let's go to the if the object class had a compare method, our life could have been even easier. Okay, let's go to Java object. දැන් මම කියන එක තේරෙන්නේ නැත්නම් ආයෙ කල්පනා කරන්න තේරෙන්නේ නැහැ කියලා දමල කාලා හරියන්නේ නැහැ. හරි. මොකද මේවා තමයි software developers ලට ඕන වෙනවනේ. Okay, බලන්න object class එකේ තියෙනවද කියලා compare method එක equals නම් තියෙනවා. But what we need is not equal. But what we need is whether, because we have to compare, sometimes we have to check whether this object is same as the other object. Okay, that is not what we need right now. So you can see, unfortunately, we don't have it, right? Or the object class doesn't have it. So then we can say you have to implement the compare method, which I will call, right? Which I will call, or runtime your code will be called. Okay, so that is how you have that is the formal or the proper way of doing it, right? Comparable interface in Java. Of course, even you can write your own interface. Okay, so then you have to compare two methods which must return maybe positive if x is bigger than y, negative if x is smaller than y, 0 x is equal to y. So that is the similar logic you can see. You can see positive integer if the current object is greater than the specified object. Negative integer if the current object is less than the specified object. What is mean by less than? It depends on that you have to decide. That you have to decide. That I don't know. I'm just right. How I know how to compare your apples, right? Or apple compare කරන විදිහ මම දන්නේ නැහැ නේ. මිලද, බරද, වර්ගඵලයේද කියලා. So that you decide and you write that code. Because we can't do everything. අපිට කරන්න පුළුවන් දේවල් තියෙනවා, බැරි දේවල් තියෙනවා. බැරි දේවල් ටික අපි ඔයාට ඉතුරු කරනවා. ඔයා ඒක කරන්න ඕන. මොකද ඒක අපිට කරන්න බෑ මේ වෙලාවේ. මේ වෙලාවේ ඔයාගේ හිත කියවන්න බෑනේ. අනාගතේ ඉන්න මිනිස්සුන්ගේ. So that is why we call it interface. That is what is called reusability. Okay, so this is the most important concept in software development, object oriented. That is why people use object oriented programming. Some of them are object oriented වලට මෙච්චර මිනිස්සු කැමති කියලා. ඔන්න ඔය කතන්දර අහන්න. හරි. So when you are using collections also you can do it. But then they have to implement the comparable interface because you are calling it. Okay, right. So that you have to do. I will modify the code and do it next time. But for the time being, I will just assume it is integer. Right. In the exams, you don't have to do the comparable interface and so on. You can just do it for integer. Right. Exam එක target කරන්න එපා ඉස්සෙල්ලා. හරි. exam එකක් කියන්නේ exam pass වුණා කියලා ජීවිතේදී නෑ නෑ මිනිස්සු. exam pass වෙච්ච හැමෝම කියලා software developers ලා වෙන්නේ නැහැ. හරි. exam pass වෙච්ච හැමෝම IT field එකේ වැඩ කරන්නේ නැහැ. හරි. ඔයාට එහෙම කරන්න ඕන උවමනාවකුත් නැහැ. හරි. ඔයාට එහෙම කිසි ප්‍රශ්නයක් නැහැ. හැබැයි ඔයාගේ ඔළුවේ තියෙනවා yes I do my IT degree but I want to have a career in maybe something else. ඒක ඔයා තීරණය කළා. මම දන්නේ නැහැ. ඒක මට කියන්න බෑ. maybe accounting නැත්නම් මනාලියන්ට ඇන්දීම නේද? ඔයා කැමති එකක්. I don't mind. So every job is good job as long as නේද? ඔයාගේ නමින් ආණ්ඩුව සල්ලි අච්චු ගහන්න නැත්නම් ඕන ජොබ් එකක් හොඳ ජොබ් එකක් එච්චරයි. ඔයාගේ නමින් ආණ්ඩුව සල්ලි අච්චු ගහනවා නම් ප්‍රෙස් එකේ ඒ ජොබ් එක කාලා ගන්න ජොබ් එකක්. ඔයාගේ නමින් ඒ කියන්නේ බදු එකතු කරලා පඩි ගන්නවා නම් අවුලක් නැහැ. ඒක අවුලක් නැහැ. එහෙම නෑ රටේ. මම කිය රාජ්‍ය සේවයේ පා කියන එක නෙමෙයි. හරි. ඔයාගේ නමින් සල්ලි අච්චු ගහනවා. ඒ කියන්නේ ඔය බලහත්කාරයෙන් ජොබ් වලට යන්නේ උන් ඉන්නේ. පන්දන් අල්ලලා යන්නේ උන් යන්නේ. එහෙම ජොබ් නැහැ. එහෙම ජොබ් නැහැ. ඡන්ද ගන්න ඕනවට දෙනවා. Don't get into that kind of කාලකන්‍ය. apply කරලා එහෙම ජොබ් එකකට ගියාට කමන්නේ. ඒවා genuine jobs. එහෙම රටේ අවශ්‍යතාවයක් තියෙනවා. මොකද අපිට ඕනේ post tackle කරන කට්ටිය ඕන, උපැන්න හදන කට්ටිය ඕන, මරණ සාතික හදන්න. හැබැයි හැමෝම ගිහලා උපැන්න සාතිකයි මරණ සාතිකයි හදලා හරියන්නේ නැහැ. ලංකාවේ හැමෝම ඉගෙන ගන්න උපැන්න සාතිකය හදලා දෙන්න, මරණ සාතිකය හදලා දෙන්න, චරිත සාතික දීලා දෙන්න. software develop කරන්න වගා කරන්න එකෙක්වත් නැහැ. වාහනයක් හදන්න, ටීවී එකක් හදන්න එකෙක්වත් නැහැ. එකෙක්වත්. ඔක්කොම උන් ගිහිල්ලා උපැන්න සාතික ලියනවා. චරිත සාතික ලියනවා. Right. So we'll do it for integers for the time being, but you have to convert it to a framework. Okay. You have to convert it to a framework. You have 1 week for that. You have 1 week for that. Right. So let's write it for the integer. Right. So therefore I will convert this to, I will assume that it is integer. Okay. But this is not the proper way, but this is good enough for your exam. Or you can just say here node class itself is an integer. Okay. Oh, that is easier. Okay, let's make it integer for that. But you have to implement it for object by yourself. Okay, integer. Or even you can say int. So then of course this must also be int. Okay, let's make it int. Then of course we know how to compare. So then, of course, I don't have to do anything. I can just compare like this. So if data is bigger than, of course, now it is int. If data is bigger than current data, I have to go to the, my data is bigger. That means I have to go to the right. Current equal current dot right child. I have to go to the right hand because my data is bigger than that. Okay. Else, let's assume that they don't give you the same data, because if it is a, now no one asked that question anyway. In my binary search tree, if I have 50, 30, 40, 90, and again 40, now we are in trouble because I can't go left side or right side, okay, because 40 is 40. So therefore, we'll assume that our binary search tree, the user always insert different values. or if it is the same value, you can come up with some strategy, or you can say you are keep it in the same node, or maybe you can just keep a counter saying there are two data values like that. So that is a very special case. But in general, let's assume our binary search tree doesn't have duplicate values. Okay, fine. So that is my assumption. That is normal assumption we do in binary search trees, because it doesn't make sense to have the same value twice. Right? Or you can say else, or anyway, if same data is added, I will give an error message. Okay, else if so data is less than current dot data. So then I have to go, because data is less, I have to go to the left side, because this particular data is smaller. Current is current dot left child. Okay. Else, that means the same. I'll give error message. Data duplicate error, or duplicate error. Okay, because you try to add the same data twice. Right. So now is it over? No, right? Now when you go to the right child or left child, if your left child or right child is null, that's it. Otherwise, yes, you go to the right child, and again you are coming to the while loop. Again, you do this, you check with the current child, current value, current node, and you keep doing that. But the moment your right child is null, that means your new node must be the right child of the current node. So that is why I told you that otherwise we have to take another reference variable. But I just want to use do it in one single reference variable. Now what you have to do? If aluten ආව current, if current, that means the new current, equal null, that means we are in the proper place, right? So the current is the place where the new node need to be added. So therefore I will say current dot, because remember we are looking at the right child because the data is bigger. So therefore the current right child must be the node that we just created, n, because we check the right child, and right child is null. The new right child is null. So we have to do the similar thing in the else if part, but this time if new current is null, because new current is the left child, then no, we have to do it before going to the current, right? Yes. Yeah. So yeah, let's not do this. Okay, let's not do this. Before doing that, let's do it. Okay, so that is better, because otherwise again we are late, right? So let's not do this. Let's do it here, because otherwise again we have already go past the current part. So why don't we just check like this? If current right child, we have not yet changed the current. If the current, now remember data is bigger than current dot data. Okay. So therefore, now our data must go into the right hand side. Now we check whether current right child is null. If current right child is null, current right child must be the new data. Okay. Else, now we have to go again to the right side. Current equal current dot right child. So we have to do the same here. So not this. If current dot left child is null, that means the current left child must be the new node. But again, you have to have an else part. If not null, yes, I can go into the next level. Again to the its next level. But if you do this, we are done. If you do this, we are done because this is a never-ending loop. So then you have to break it. Okay, break. I told you we can use break, but with a lot of caution because it's a little bit unstructured, but sometimes break is really handy. Right, so that is my implementation. Okay, so think about it. Then class එක ඉවරලා මොකද කරන්න ඕන? මේක තනියෙන් implement කරන්න ඕන. ඔය note එකයි code එකයි මුකුත් බලන්න නැතුව. වරද්ද. හරි වරද්ද. කී පාරක් කරද්දුවත් කමන්නේ නැහැ. රෑ එළි වෙනකන් code එක කරත් කමන්නේ නැහැ. So එහෙම තමයි මිනිස්සු ඉගෙන ගන්න. Right. So then I can't 100% assure this is working because there can be bugs. Okay, because I am a human, but I feel like I think now it's working. It should work. Okay. Right. So now how to test? Because there are two ways to test. One way is why they say that. Right. So this one. Right. Semicolons are missing. Right. No errors. So one way is you create the insert it and do a debug and see whether it's properly done. So that is one way. Okay, so that means you come to somewhere here. Okay. And you know what should be the final outcome, right? So this is the final outcome. 40, 80, this should be the final outcome. 20, 60, 30, 10, 70, 90. Right? So one way is you debug and see, otherwise you have to implement the traversing method. Okay. Right. So let's debug and see. Because we can see our data, the root node. Still, it's a debugging start. Okay, why they say that? And why is there's a null point exception? So that means there's a bug. When I insert this one, okay, it comes from this point. If data is bigger than current.data, why we are getting that? Can anyone find what is the reason? If data is bigger than current.data, that can be okay, right? Current can't be null because current is initially root. Root cannot be null because if root is null, yeah, I think if root is set, anyway, it won't come to else part. So is it for which data we are getting there? 830 දානකොට වැඩි වෙලා තියෙන්නේ. Why is that we are getting that error for 30? Okay, let's do a debug point. That point, debug. Right, so far. And when we insert 30, only we get that null point exception. So, okay, now I will go into the step in. මේ ඉගෙන ගන්න time subject එක තියෙන්නේ step in මේ debug එකක් කරගන්නේ කොහොමද වගේ දේවල්. හරි? That is part of that. Okay, so now I have created a new node with 30 because data is 30. Now at least I can check whether up to this point it is correct. right? දැන් 30 දාන්න හදන්නේ. එතකොට මේ විදිහට දාලා තියෙන්නේ මොනවද? 40, 80. So this must be the binary tree right now. 40, 80. Let me draw it. 40, 80, 20, 60. ඔන්න දැන් තමයි 30 දාන්න යන්නේ. මේව තාම නෑ. Right. So now let's see. Now let's see whether the binary tree is correct. So this is my root. Root must be 40. Yes, root is 40. Root's left child must be 20. Left child. Yes, it is 20 and it has no left child or right child. That is okay because still we are in these blue circles. Okay. So that part is okay. That means that side is okay. Now let's go to the right child of my 40. It must be 80. And it must be having a left child, but right child must be null. Okay, this data is 80. It has a left, you can see right child is null. That is fine. Right child is null. And the left child must be having 60 and its left child and right child must be null. Yes, 60. Yeah, that means up to this point, it's okay. Right? So that means when we insert 30, why we are getting this error? Okay, let's see. Right. So now let's see, because up to now the data structure is properly inserted. Data is properly inserted. That means it's a strange error. So therefore now let's see. Let's step in. Right. So the node is created part is okay. Right. Now is root null? No, root can't be null. So therefore we must go into the else part. Yes. Now we set the current as the root as the current. So that is okay. Now because these are always true. Right. So now what we do? The data is, remember, data is 30. Now we try to insert 30. Okay. Now we try to insert 30. This is what we try to do. So therefore it must first come to the left side. Current data is, don't remember the current is 40 root. So data is 30. So therefore 30 must be smaller than 40. So therefore data will be, it won't go to the if, it must go to the else. Okay. So let's see. Yes, it came for the else if. Okay. It came for the else if because my data is less than current. Current is still in the root. Right. So therefore, yes. Now I check current left child because I want to go to the left side. Still I am here. Still I am in the root because this is the first iteration. So therefore I have to data is less than current data. Therefore I am checking whether current's left child is null. Because if current's left child is null, 30 can be there. But of course, current left child is not null. So therefore, I will not come to this inner if I should go to the else. Yes. So therefore, current is current right child. It must be current left child. On the bug එක හම්බුණා. මෙතන copy paste නේ කරේ. Right? ඔන්න bug එක හම්බුණා. ඔන්න ඔකට තමයි debug කරනවා කියන්නේ. දැක්කනේ? මට ඔක අංජනම් බලන්න බෑ. ඔක ඔහොම තමයි debug කරන්නේ. නැත්නම් ආයි code එක A to Z කියවල තමයි කියවද්දි මේක අහුවෙනවා. මේ right child නෙමෙයි left child කියලා. Got it. So that is how you develop software. Okay? මේ develop software develop කරන එකයි වඩ ගන්න data structures ගන්න එක දෙවෙනි වැඩක්. හරි? It's a secondary thing. So the main thing is at the end you must know how to get out of problems, right? How to come up with solutions. Right. So therefore, remember data is less than current data. Therefore, I have to go to the left child because this is the left side. Right? Left child. මොකද ඔතනදී තමයි ඉස්සෙල්ලාම පිට දකුණු පැත්තට එන්න ඕනේ. Data is less than current data. So therefore, you have to go to the current must be the left child. Right. So now it should be okay. Now I'll stop it and debug again. But debug up to the final point. Okay. So that means I don't want to stop it here. debug. Right, no null point exception now. Now let's look at the data structure. Right, so root must be 40. Yes, and it has left child and right child. Let's go to the left. 20, correct, and it must have a left child and right child. Left child must be 10. That is that. Left child is 20. 20 is left child must be 20. Left child is 20. It must have a left child, which is 10, right? And it must be having a right child, which must be 30. On the right child, දාලා නෑනේ. ඇයි 10 right child නැත්තේ. පොඩි අවුලක් තියෙනවා නේද? So root is 40. 40 has a left child. මම data add කරලා නැද්ද? 40, 80, 20, 60, 30, 70, 90, 10 තියෙනවා. Okay, let's double check again. So the left child is 20, fine. Its left child must be 10. Okay. It doesn't have a left child or right child, correct? All right. And this one's right child must be 30. 30. Yes, it has no left child. All right, correct. Right. So now we are going to the root's right child. It must be 80. Yes, it has both left and right. Let's go to the left child. Left child must be having 60. And its left child is null, but right child must be there. Yes, 70. Correct. And this one's right child is 90. And it must not have any left child or right child. Yes, done. So that means insert is properly happened. Now the data structure is in the memory, properly created. Right? So that's it. So that means the data structure is properly created. So that means my insert method is working. Unless there are any odd, very special case error, I hope there's nothing like that. Okay. Right. So that's how we insert. Then what තනියෙන් මේක කරන්න ඕන. කළා බලන්න ඕන හරියට data structure හදනවාද කියලා. Right. Whether you get the data structure properly. So of course you can use slightly different approach. I don't mind. Okay. I don't mind the way you do it, but try to come up with the simplest possible solution. So remember, the best solution is simplest solution, the most efficient solution. So less number of processing, and also it's a simple solution. Usually simple solutions are efficient. Okay. Right. So now we are done with insert. Okay. Now we are done with insert. I think pretty much the same thing. හැබැයි ඊටත් වැඩිය ලේසියෙන් කරලා තියෙනවා. current data නම් මම break කරලා තියෙනවා. එච්චර ලේසියෙන් කරේ කොහොමද? That is search, right? That is search, not the insert. Right. Insert, yes, I think that is the way to go. Right. ඔය විදිහට තමයි කරන්න වෙන්නේ ගොඩක් අය. මෙතන තව එකනේ පිටිපස්සේ එකක් ඇවිල්ලා තියෙනවා. පේනවද? current and parent. Parent passing එකක් ඇවිල්ලා තියෙනවා. But without doing that, actually I made it even better. Right. So මේකටත් වඩා lazy වුණා because you don't have to take the parent, because we can just survive with the current. I think this solution is even better than the one in the your node. So I will be adding this solution to your new node. Okay, new node. Because I told you that there's nothing called this is the correct approach. So you can always improve things. Okay, right. So if you can come up with an even different solution, but as long as it is easier than, simpler than this, that is good. Otherwise, still you can be happy that your solution is working. But the moment you find a better solution, you have to say that, okay, my solution is working, but I accept your solution as a better solution. So we must be very honest in life. Okay, we must be very honest in life. If someone come up with a better solution, you have to say, yes, your solution is better than my solution. So from maybe you can say, okay, from this time onwards, I will be using your solution because I want to come up with the best solution for my customers, not show off my things. Right? Right. So any questions on the insert method? Insert method. So you have to do it by yourself. Start from fresh. Okay. Right. So that is how you do the insert in the, how do you implement the insert of the binary search. Right. So now let's introduce few more functionalities. Okay. Few more functionalities. So let's implement. Now remember you have another task, that is make this sort of a framework so that user insert whatever, apple or dodol or whatever, but the user must implement the compare method. We just call that method. There was solution name what? There was no what හොඳට interface කියන එක තේරුම් ගන්න පුළුවන් අද. මම මේ කියන වැඩේ කරොත්. So what your task is, we can say don't send just object, something, right? Something that you implement that interface. Why? Now remember I told you interface is a contract. මේක තේරුම් ගත්තොත් ඔය object oriented එලකිරි වගේ දන්නවා. Remember what is the purpose of interface? Interface is a contract. For example, when you build a house, you have a contract. What is that contract? Your plugs must be, now they can plug based, so it must support this kind of a thing. So that is the interface. So the government also said, has mentioned that, okay. So this is the interface we support in Sri Lanka. So therefore, when you build a house, what you do? You fix this kind of plug, plug base, plug base everywhere. Because government has assured that when an electric equipment comes to Sri Lanka, it must have this type of a plug. This type of a plug. Plug base. So that is a contract. Now in the future, new electric items will come to Sri Lanka as long as they support this plug, it will fit into my plug base. But I don't know what kind of functionality you will be doing. But you have to comply that your if you want to take the electric power, your plug must be something like this. So that is the interface. An interface. Okay? So what we are doing is also something like that. So therefore, what you have to do is, we have to say that it's not objects. It's not object. You have to send something. Say search objects or whatever. So rather than object, you call it search object. You create a class called search object. That's what our solution is. Yeah. So, but that search object has to implement a particular interface, and that interface must have a particular method. That method you call in your code, but you have not implemented it, right? And let user implement it, and add those search objects. As long as they add the search objects having implemented that interface you define, your code must work. And both must be happy. You are happy because your code is working. The one who is using your binary search tree is happy because things work. But they have work to do, that is implement that method. So then your code and their code working hands in hand. So now you are in control when it comes to binary search tree. So therefore, they don't want to implement the binary search tree functionality, but you rely on them implementing the compare method or whatever the method you call it. But how do you get into that agreement? With the help of interfaces. ඒකත් හරියට අර plug එකේ මේ විදිහට කියලා අපි agree වුණා වගේ වැඩක්. So we just agree on the method signature, nothing else, because we call that, we expect that you implement that particular method. Okay, right? So think about it. ඕක ඉවරනකොට data structures පුළුවන් වෙලා object oriented පුළුවන් වෙලා finally project එක ගැනම තියෙන බය සංකාත් නැති වෙනවා හරියට කරගත්තොත්. අපිට ඕනේ ඉතින් වැඩක් කරන්න පුළුවන් මිනිස්සු මිසක් වැඩක් කරන්න බැරි සාතිකධාරියෝ නෙමෙයි. ලංකාවේ ඉන්න සෑහෙන උපාධිධාරියෝ IT කාර්යෝ අර නේද කාර්යෝ කියන්නේ සාමාන්‍යයෙන් කියන්නේ ඒක මම කියන්නේ ඒක අගෞරවයක් නෙමෙයි. IT කාර්යෝ උපාධි කාර්යෝ වඳුරකට පායින් ගහපු ගමන් නේද ඔලොගුවත් ගලවගෙන එළියට පායින්. හරි. සාතික මිටියක් බෙල්ල ඉල්ලගෙන. Right. So that is you have to do. Now let's implement few more methods. Right? Few more methods. So now let's implement the find method. Find method. So find method, I don't tell you, I don't give you the implementation because I want you to implement it. Okay, I want you to implement it. But let's discuss what strategy. Let's discuss a strategy. Right. Now, how do you want to start? Say I have a tree, something like okay, so that is okay. Let's assume I have a tree like this. Say 80 is there, 50 is there, 40 is there, 70 is there, 100 is there, 90 is there, and maybe 95 is there, 60 is there. Okay. Now, how do you find search something? Because remember, this is called binary search tree. Say I want to search whether 70 is there. 70 is there. Now, what is your task? Remember, you have the access to the root. You have the access to the root. You come and check whether what you are looking for, in this case 70, is it equal to that? That will be your current. Current is root. Okay. If it is equal, you are done. You have to say yes, true. True. True, false return can. So the method will return true and true or false. If your data is data that you are searching for is smaller, you have to, your current must go into the left child of the current, because if it is lesser than 80, it must be, if it is there, it must be in the left side. And again, you check, is this current dot data equal to 70? No. So then you have to say, is it bigger or smaller? No, it is bigger. Then you have to go to the right child, because if it is there, it must be in the right hand of this one. Now your current is here. Now again check, is it same as this? Yes, it is same as this. You just say true. True, return true. Okay, so now you have to write that general logic. It's super easy. And if you are searching something which is not there, what will happen? Now say you are searching for 75. Of course, 75 is smaller than 80. You come here. Bigger than 50, you go there. Bigger than 70, therefore you have to go there. But when you go there, if it is null, if that means that number is not equal to this. But when you go to the left or right, if it is null, that means the data you are looking for is not there. You have to say false. As simple as that. Now I gave you the logic. Your task is implement the logic. It's easier than insert. Actually, you must be able to write that code in 5 minutes, and then do a search. Right? Do a search, because it must return true or false. I will just write the method signature. I I will just write the method signature. Okay, let me delete the doc. Right, so let's say return Boolean. Say find. It will return true or false. Okay, so you have to send. Remember, now we have changed it to the integer. You have to make it. Object. Okay, and if you want, you can just send me the code, or you can send the code to the WhatsApp group. Your final code with that general implementation. Okay, right. So I'm doing it for the int only. Say D or whatever. So I will just return false for the time being, but you have to implement the entire code. I'm just returning false because otherwise they have become errors. So then I will write the test case also. Oh, yeah, we having errors. So then you can do something like bst dot find. Maybe you can find something you have already added, like 30. It must return true. If you don't get, of course, initially it doesn't always return false, but it must return true. Okay, see whether you get true. It return a value, so therefore even I can call it in a system out println. And it must return true. So you have to implement this. So maybe you can test it for few data. So you have the quality assurance subject in next year. So there we will discuss what kind of scenarios you have to test. We have to look at positive cases, negative cases, extreme cases, right? When you are doing testing, right? So let's do negative case where there's no such data like 55. So then you must get false if you have properly implemented it. And if you are getting null point exceptions or true when it comes to when you are expecting false, that means there are bugs. There are bugs. Okay. Right. So that is something you have to do. Implement the find method. Okay. Right. So another method which you can do is find the minimum value in the binary search tree you are having. So of course, by that time you must have some data in your binary search tree. Find the minimum value. Then find the maximum value. Can you think of a solution? Can you can someone explain me the solution in plain English? So Boolean, sorry, not Boolean, because we are using int. You have to change those to object later. Int, say find max. So then you don't have to send anything. We will return the max value. For the time being, I'm just making it -1 just to prevent error messages. You have to write the code. So it must give you the maximum value or the biggest value in your binary search tree. So the next one, find min. So that you must return the minimum value in your binary search tree. Okay, so first do the min, then do the max. Anyway, just the same logic, just one place you have to do the change. So these are the exercises for you guys. Okay, find method, find min method, find max method. Super easy. Those are not difficult things. Okay. Right. Insert method we did. Right. So the next thing is we want to traverse the binary tree. We want to traverse the binary tree. Traverse means visit all the nodes. So traverse means Visit all the nodes. Actually, the binary tree is super interesting topic. Of course, if you like programming, if you like problem solving, okay, super interesting topic to learn programming, learn problem solving. So that is why every degree program, IT, computer science degree program has data structures and algorithms. Okay. So again, I'm telling you, this subject is not to make you familiar with that structure, that method, this, no. Of course, that is also important. The most important thing is while you are doing this subject, you acquire the touch of software developer. That mindset, those skills, debugging skills, Google search skills, getting help from others, right? All these things, all these attributes of a software developer. Okay, right. So another interesting thing we can do with binary search tree is traversing. So traversing means visiting all the nodes. Visiting all the nodes. ඒක හරියට අවුරුද්දේ නෑගා යනවා වගේ. හත්මුතු පරම්පරාවේ නෑගන් යන්න ඕනේ සමහරුන්ට නේද? අම්මගේ පැත්තේ කට්ටියයි තාත්තගේ පැත්තේ කට්ටියයි එක්කෙනෙක්වත් අග හරියොත් මේගොල්ලෝ තරහ වෙයි. අන්නේ නැත්තම් කසාද බැන්දට පස්සේ වරිගේ හම්බ වෙන්න යනවා වගේ. අපේ ලංකාවේ සංස්කෘතියක් තියෙනවනේ එහෙම නේද? වරිගේ හඳුන්වලා දෙනවනේ අනිත් එක්කනට. Something like that. Okay. So how do you do it? ඉස්සෙල් ළඟම කට්ටියට හම්බ වෙන්න යනවද නැත්නම් ළඟම නෑ හම්බ වෙලා ඊළඟ ලෙවල් එකට යනවද නැත්නම් අරගොඩ තරහ වෙයිද අපේ ගෙදරට එන්න කලින් මුන් අරගොඩුන් ගෙදරට ගියා දුර නෑයෝන් ගෙදර ගිහිල්ලා තමයි අපේ ගෙදර එන්නේ කියලා. So there must be some sort of a logic. Right? There must be some sort of a logic. And of course there can be multiple logics. It depends on your requirement. නැත්නම් අපි ඉස්සෙල්ලා දකුණු පළාත කව කරලා ඊට පස්සේ යනවද නුවර? නේද? Likewise there can be some logic, right? You can use. So in binary search tree also there are different approaches or logic or tactics you can do when it comes to traversing. Okay. So in general there are two types of traversing called depth first traversing. Actually search is not the best word. Sometimes people use search. Depth first traversing and breadth first traversing. So depth first, breadth first is the easier one to understand. You stay in the breadth. So that means you first traverse the children close to you. Then you traverse the next level children, and so on. You go in the breadth. You stay close to the root. When these are done, only you go to the next level. So that is called breadth first traversing. You traverse through levels. In program, because you have to write a program that you go first here, then you have to say this is A, B, C, D, then your output must be A, B, C, D, E, A, B, C, D, E, F, G, H, I, and so on. Okay, so that is called breadth first traversing. The second approach is called depth first traversing. So that is, you don't just go by levels, rather you try to go into the depth. But when it comes to that, there are again different approaches you can use. Okay, so therefore in depth first traversing, we have three sub approaches. Right? What is called pre-order traversing, in-order traversing, and post-order traversing. Okay, pre-order, in-order, post-order. So we can use one of the approach in depth first. But breadth first is straightforward. You stay in the level 1. Remember, this is level 0, and then level 2. Then if there are level 3, and so on. But again, the implementation is not as simple as you may first think. Because remember, you only have the access to the root. Of course, you may be able to implement come up with a solution, but it may not be the best solution. So here we try to understand what is the easiest, simplest, the most efficient approach. Okay, but it doesn't mean that other approaches are wrong. Of course, something is better than nothing. Okay, so therefore, you might try something first, and then see whether the approach given in your note, in your syllabus, is it better than your one, or is it your one is this also the same level? Okay, right. So let's forget about the implementation for the time being. Anyway, we are going to implement the search methods because it's super easy using recursion. So this is where we can use recursion for our advantage, because this traversing is highly recursive in nature. I told you that recursion can be used in a very smart manner to solve. So, but it looks very complicated problem, all of a sudden become very simple problem. If you know what is recursion, if you have experience using recursion, that means you have the guts to confidence to apply your knowledge about recursion. Right. So let's first look at what is pre-order traversing, because breadth first traversing you can understand, right? If I give you a tree, you will just write down what is the outcome. Like for example, if I give you, say, 70. Okay, let's take the previous example. Okay, it's not in the undo. Right, so let's say 60, 50, 40, 20, 80, 70, 75, 100. Okay. Right. So this is what pre-order traversing is. Remember, it's a depth first traversing. Of course, if it is a breadth first traversing, the outcome you can write, right? 60, we are in the level 0. Then level 1, okay, let's say we are going from left to right. 50, 80, then 20, 40, 70, 100, and now we are into the next level, 75. Of course, implementation, you have to think. Okay, today we don't do the implementation. I let you think about the implementation. Maybe some way, not the best way, or whatever the way. If you can think of some way, and if it is working for any binary tree, because you can now, we have the insert method, you can create binary tree of any number of data. Okay, and when you create a binary tree, everyone must get the same tree, because there's a logic. When you insert these data, you can't say I got this binary tree. No, it can't be. Everyone must get the same binary tree. Okay, because we have a definite logic. Right, so that is breadth first traversing outcome. So let's look at what happens when you do a depth first traversing in pre-order. So this is a very good exercise for you to think recursively also. Okay, think recursively. So this is how we do it. Pre-order traversing, we do it like this: current, left, right. That is a strategy. Current, left, right. You have to do it recursively. හරි, දැන් recursion වැඩි ඔළුවේ නැති අයගේ ටිකක් කැරකිල්ල හැදෙන්නත් ඉඩ තියෙනවා. ගණන් ගන්න එපා, ටිකක් කරලා යනකොට කැරකිල්ල හරියනවා. Right, so this is how you do it. So you have to always start with the root, whatever the traversing we do, because we have this root. Therefore, there's no other place to start but start with root. Okay, right. So in pre-order traversing, we do it like current, left, right, but you have to do it recursively. Okay, right. So when you say current only, you print it. When you say left or right, that means you have to recursively go to the next level, but you have to keep track of where you came from. Okay, so this basically check your capacity of thinking also. How much you can understand what you are doing. Okay, right. So this is how it happens. Current. if you say current, it must be in the output. Right. So now this is done. Left. Remember, if when we say left, you don't put it in the output. When you say current, only you put it into the output. So therefore now, remember the order is current, left, right. Current, left, right. Okay. So current 60, left. Now you are recursively doing again current, left, right. Current. So that means 50. Right. Then again left. Left means again you have to do it recursively. Current. Right. Left, nothing. Right, nothing. So that means we are done that. Remember we came current, left. Now we have to go to right. When you say right, again you have to say current. That is 40. Left, nothing, right. If nothing, you don't print anything. Now remember you came current, left, right. Here you came current, left. Now you have to say right. Right. Then if you say right, again you have to say current. Then left. When you say left, you have to say current. Left, nothing. Right. Right means current. Remember, this is your current, left, right. This is your current, left. Now you have to say right. Then current. That's it. Then left, right, nothing. And nowhere else to go because now all your recursives have returned. So here, remember, current, left, right, done. Current, left, right, done. So that you come back here and you stop it. And the output is 60, 50, 20, 40, 80, 70, 75, 100. That is the output. You just went through current, left, right, current, left, right, current, left, right. And at the end, you have visited all the nodes and this is your output. And this is your output. 60, 50, 20, 40, 80, 70, 75, 100. Okay. Right. So now we are going to implement it also. Okay. We will implement the pre-order traversing because it's a recursive thing. Sometimes you may not be able to get it. So therefore, let's do it by ours in the class. Okay. But if you want, okay, how can I say? If you want, you have to now get out of the class because we are going to do it. Okay. Right. So so therefore, let's do the implementation. It's super easy actually using recursion. Okay, using recursion. But you have to implement the find min, find max, find methods. Okay, those methods. Right. So this is how we do it. So let's call these methods you have to implement. Let's call it pre-order traversing. Say it's return void pre-order traverse. So what you have to do? Let's assume you always start with the root. Of course, if you want, you can just send me a particular node and from that point onwards also we can do it. Let's assume we just do it for starting with root. So remember that how do we go? Current, left, right. But current means you have to print the value. Okay, print the value. So then when you say left again, you have to call the same logic because there also you have to do the current, left, right. Current, left, right. Okay, but next time you have to give your current. So therefore, if you don't have a parameter, you are in trouble. Okay, you are in trouble. Because next time when you call, you must know what is your current is. Of course, first time you can assume that it is the root, but next time. So therefore, we have to introduce parameter for this one. And it must be of the type node. Okay. So let's say current or C. So therefore, what we have to do, you print the current current.data, which is in our case integer. Then you have to do is you have to call recursively for current.left or your c.left child. Then you have to call again your pre-order traverse, but for current.right. When you keep doing this recursively, you have done the pre-order traverse. But for the first time, you don't have to send something like this. If you send this, you are traversing from that point onwards. So therefore, let's do and write another method that we let the user call that one void pre-order traverse. I just want to give it a different name, or I can even do the overloading, but I just write different name. Pre-order traverse. Pre-order traverse. Okay, let's say traversing or something. But that you don't have to send anything because the user will call this one. Okay. But here what we do is we call this one with the root, because root the user doesn't have the access to the root. We have access to the root. Right. So this should work. And let's see if there are bugs, we will fix it. So when the user call this, we call this method with root because we have the access to the root. And then it's keep recursively printing the current value and then calling the left and right this one. Okay. So the end results must be we are having the pre-order traversing. Okay. So let's call it say S out pre-order traversing. Remember, these find methods are not yet implemented, so therefore you will always get false. Okay. අපිට අනිත් method දෙකක් දැන් call කරලා තියන්න පුළුවන්, but it is not doing anything. SOUT, sorry, not SOUT. Let's say, yeah, SOUT, BST dot find max. Those things you have to implement because those are super easy things. BST dot find min. Find min, find max. Okay. Of course, this one must be find min must return 20. Okay, let's do the find min first. So these are the possible the correct outcome we are expecting. Of course, still it is not implemented. Find max must return you 90. Right, but we have implemented the pre-order traversing. Say our BST, our reference variable dot, we use this method because we don't have anything to send there. Okay. So then what must be the outcome of this if we have properly implemented? So let's again build this. So we have 40. 80, 20, 60, 30, 10, 70, 90. Okay. So what must be the outcome when we do the pre-order traversing? Yeah. So So when you do the pre-order traversing, remember current, left, right. When you say current only, you print it. Current, left, then current, left, then current, left, right. So then you came current, left, you have to say right, then current, left, right, nothing. So then you're coming back about the left. Now you have to say right, then current, left, current, left, right. Right means current, left, right. The right is also done. Left came, right, right, current, and then no left, right. You are returning, and you are returning. Like recursion always තියෙනවා. සතියක් තිබුණ එකත් recursion එක practice කරන්න. So this must be the outcome if I have implemented the pre-order traversing properly. Right? Because we are sending it with root, then we are calling it recursive. Okay, so this is not a simple recursion. So this sort of a this recursion goes in two direction. Okay, two direction. Okay, let's run it and see whether we get the correct answer. Otherwise, there's a bug. Right? Otherwise, there's a bug. So this must be the output if you have done it properly. Okay, right. So let's do this in the same line because otherwise we will get the output in the next line. Okay. Yeah. So let's use print and maybe something like this. Okay, just to make it nice. Of course, the last one will also have a arrow. That's fine, right? I'm not interested in removing that arrow. Okay, I just want to print it in the same line. Okay, otherwise it will take a lot of space. Okay, let's run it. Right, so you get error. We get 40, 20, 10. Then, as usual, the 30 we have issue. Why is that? This 30 is always giving me the headache. Why is that? Okay, let's see. 48. C.data. Yeah, maybe when this is null, if this is null because your left child or right child can be null also, right? So therefore, we have to remember when you are doing, now remember we learned the theory, but we forget the theory, right? Remember when you are doing recursive calls, there must be a way out condition. So we discussed the theory last time and forgot to apply it. So if you go for this kind of recursive call, there is no way you can get out of it. So to get out of it, you keep doing forever and get out of memory. Or else you neither one එක දිගට ඔහෙ ගියොත් එහෙම එක්ක අතප්පයක් කඩා ගන්නවා නැත්නම් පාර දිගටම තියෙනවා. අනන්තයේ දිගට යනවා. So this is අතප්පයක් කඩාගෙන තමයි එළියට ආවේ. Null point exception එකක් වැඩි. Because when you say your next left child if its data is not, if it is null, its data is also null. So කෙලින්ම යනකොට අන්තිමට null point එකක් ආවා. So therefore you have to stop, you have to make sure that you stop your recursion somewhere. What is that point? Right. So when your left child is null, right? So let's go to this one. So if your C is null, you have to stop it because if it is null, of course there's no data. First thing, and of course there's no left child or right child for that. So therefore there's a bug. You can see. So bug is, now I can fix the bug. If C is not equal to null, you do it. Otherwise, that is our way out condition. So that is our way out condition. Else, don't do anything. So that means you are effectively ending the recursive branch. So else you don't have to say anything. Else means you are not calling again. Right. So now that bug should be eliminated. Let's try it. That is how you develop software, right? Because we are not perfect right? Humans, right? 40, 20, 10, 30, 80, 60, 70, 90, correct. Okay, 70, 90. Now remember, of course, if you can do it in the first step, that is fine. But remember, every time you make a mistake, you are one step closer to the success. You are one step closer to success. But if you are not doing anything, right, you are ever kalakanya. You are ever kalakanya. That means you don't do anything. You don't do anything. So that means you are not getting success, closer to success. So you are not getting closer to anywhere other than that word I use. Right. So therefore, now we are done. So this is the result of pre-order traversing. So in pre-order traversing, what is the approach? Current, left, right. You keep doing this, right? You keep doing this. Until you have visited all the fields. Okay. You have visited all the fields. So that is how you do the pre-order traversing. So now let's look at the in-order traversing. So only difference is the way we go. Remember, pre-order traversing, current, left, right. In order traversing, it is left, current, right. Okay. Left, current, right. Okay, so forget about the Q. Left, current, right. But when you say current, you print. Otherwise, you don't print. Right? When you say current, you print. Otherwise, you are again recursively called. Then on ඔළුව ඇතුලේ recursion වැඩ කරන්න පටන් ගන්නවා. මම කිව්වා ඉස්සෙල්ලා ඔළුව කැක්කුමක් හැදෙනවා. ඊට පස්සේ ඔළුව කැක්කුම හොඳ වෙලා recursion උත් පුළුවන් වෙලා වැඩේ කරන කට්ටියට. හරි try කරන කට්ටියට. Right. So let's see. Right. So how do you do? Left, current, right. So you have to start in the root. Left, because it's not current. Current කිව්වොත් විතරයි print කරන්නේ. So you have to say left. Again, you have to say left. Again, you have to say left, nothing. Current. Oh. Right, nothing. Nothing means you are coming back. So then remember we came left here, then current. Right. Left. Current. Right. Right can මුකුත් නැත්නම් හැරලා එනවා. Now remember we came left, current, right. For this one we came left. Now current. Right. Left. Left. Current. Right. Left. Current. Right. So this is the right of this one. This is we came left, current. Right. Left. Current. Right. That must be the output. Okay. So only difference is now the way we go by is slightly different. So let's implement it. So I just want to copy these two because same solution we are going to give. Let's call it in order traversing. Just I need two methods. Say in order traverse. So here I must call this method recursively. But only thing is where I print this. Now it is left, current, right. Left, current, right. And this must be the output. Okay. This must be the output. So let's call that second one. Okay. In order traversing, but in between I will just put up S out to take it to the next line because we don't have system print ln. Right. So let's run it and see. And this second output must be this. Okay. 10, 20, 30, 40, 60, 70, 80, 90. Second one. Okay. 20. So that means something wrong. So let's double check. In order traversing. In order traversing, in order traverse. Sorry, this is pre-order, right? So I have to call itself. So here also in order traverse. Then only you are calling yourself. Okay. Right. So there was a bug. Actually, it's a careless bug. Okay. Now it should work. Right. 10, 20, 30, 40, 60, 70, 89. And if you close look at it, you can see that this is sorted order. So this is the data is now in sorted order. So that means when you do in order traversing, you get the data in sorted order. So therefore, this is another way of sorting data. Now you learn your first sorting algorithm. So what is your first sorting algorithm? You insert your data into the binary search. Then you do the in order traversing. You have sorted. On a sorting algorithm, right? That is your first sorting algorithm. So you can see cleverly we start solving problems which look difficult, but using the clever use of data structures, recursion, and some other techniques we know, and for the structured concept, if conditions, loops, sequence. Now we are solving some serious problem. So that is what software developers do. Okay. Right. So that is how you sort data. This is one of the way. Remember, there's nothing called this is the way. There are, for complex problems, multiple solutions are there. This is one of the solution to the sorting problem. You insert into the binary search tree and do the in order traversing. You get it in the sorted order. Okay, but we never inserted in the sorted order. We just added some random data. Okay, right. So that is called in order traversing. So the third depth first traversing technique we discuss is post order traversing. Post කියන්නේ පස්සට ඉස්සෙල්ලා යනවා. ඒ කියන්නේ left right ගිහිල්ලා තමයි current එකට එන්නේ. මේ යට ගිහිල්ලා තමයි උඩට එන්නේ. That is why we call it post order. So that means left, right, current. Remember, when you say current only, you are printing. Otherwise, you have to do it recursively. Right. So let's do it for this one. Left. Now you have to start with root. Left. Again, left. Again, left is null. Right is null. Current. Remember, we came left. Now we have to go to right. Now this is done. Right. Then left, right, current. Remember, we have done the left, right. Now current. We did the left. Now we have to go to right. Again, left. Again, left. Again, right. Again, left, right, current. We have already visited left, right. Therefore, current. We have visited left. Now we have to say right. Then left, right, current. We have done the left, right. Now current. We have done the left, right for this one, current. That is your output. That is your final output. 10, 30, 20, 70, 60, 90, 80, 40. So how did you do that? We just went left, right, current. Recursively. Recursively. So let's first implement the code. Because it's super easy to implement the code now. Then now you can see the solution is easier than thinking about the solution, because we have similar problems now. So I will copy these two of these methods. Now remember, now we are into the post order traversing. Now I don't want to make the same silly mistake. Okay. Of course, I have to use post. Because one shot I want the answer now. I must call this one. And this must be called twice. And now left, right, and current. Current means print. And then I will be in. So just we have to call the post or traversing. Is how to take it to the next line. It's an instance method. Right. So it's right. And we must get this. And then I know නැත්තම් පොළවේ ගහන laptop එක. මෙච්චර mistake කරන්න බෑනේ. Right. 10, 30, 20, 70, 60, 90, 80, 40 correct. Right. So that is how you do in order traversing, pre-order traversing, post-order traversing. Okay. Right. So anyway, I just implemented that because it might be a little bit more challenging for you guys to think about it because that is why I did it. But what I gave to you are the methods that you must be comfortable implementing. Now, what are those methods? Of course, in the exams, you must know these methods, right? In order traversing, post-order traversing, because they are super easy. But you have to implement the find max, find mean, and find. There are a few more interesting methods we can implement. We can look at those things maybe next time, like finding the depth and so on. Okay. Of the tree. But I just want to give you one more question for you to build this is not a coding question. These kind of MCQs are there. You have to build the binary search tree. Then you have to write down what is the output when you do in order traversing, pre-order traversing, post-order traversing. So these are the data. Just do it. Just take 2 minutes and do it. Okay. Say 70, 70, 80, 30, 10, 40, 100, 5, 20, 90, 95. First, build the binary search tree, then do pre-order, then in order, then post order. I do it. So everyone must get the same binary tree, every same result for the 3 traverse. Now, when you do it only, you will find out whether you can do it, you have understood it or not. As long as you don't try it, you will be comfortable, you will be happy, but you are an empty bucket. When you start doing, all the problems in the world are there. So that is why those who are doing something, they have all the criticism, right? Praise, criticism, troubles. Those who are not doing nothing, so they are always happy, but Karakan. And of course, this is not a coding question. Give 1 more minute. Of course, building the binary search tree, even a grade 2 student will do it. But pre-order traversing, in-order traversing, post-order traversing, some of you might do it. Implementing this kind of a method by your own for a new problem, so that is only few of you guys will do it. So those are the diamonds. Those are the gems. In the IT field, of course, you can be a gem in music, you can be a gem in some other field, right? So try to be that gem in the choice of your field. A field එකේ මැණිකක් වෙන්න. Okay, let's add it. Say 70. 80 is bigger. 30 is smaller. 10 is big, smaller than 70, smaller than 30. 40, smaller than 70, bigger than 30. 100, even bigger than 80. 5, even bigger, smaller than 10. 20, smaller than 70, smaller than 30, bigger than 10. 90, bigger than 80, but less than 100. 95, bigger than 80, less than 100, bigger than 90. Right, so that is my binary search tree. So let's do the pre-order traversing. Pre means current, left, right. When you say current, you have to print. Okay. Current, left, current, left, current, left, current, left, right, done. Okay. You came current left. Now you have to say right. That means current. Okay. So then you said current left. Now you have to say right. Then you have to say current left, right. Now we have done the current, current left, right. Okay. Current left, right. For this one, you have done current left, right. For this one, you have done current left. Now you have to say right, current, left, right, current, left, current, left, right, current, and of course left, right, right done, right done, right done, everything is done. Now we are written. So that is how, that is output. 70, 30, 10, 5, 20, 40, 80, 100, 90, 95. Okay. So we can even test it with our code because we have the, now the code is there. Then so we added 70, 80, 30, 10, 40, 100, 5, 20, 90 and 95. 95. Let's run it. I'm interested in the first this kind of output, that is the pre-order, right? First one is the pre-order. Yes, first one is the pre-order. I will comment this because otherwise you can't do the exercise when you see the answer. Let's see whether we get this. $70, $30, $10, $5, $20. Okay, 29 type kara. Anyway, the output is going to be the same. Right, so let's run it again. Right. 70, 30, 10, 5, 20, 40, 80, 100, 90, 95. Done. Right. So that is what happens when you do pre-order traversing. Now let's do the in-order. In-order traversing are then comma done now. Sorting order. 5, 10, 20, 30, 40, 70, 80, 90, 100, 95. But let's do it in a proper way. Okay. Let's do it in a proper way. Right. So remember, in-order traversing, left, current, right. Okay. Left, current, that is where you print, and then right. Right. You have to start here. Left, again left, again left, again left, current, right, current, right. Now we came left, current, right, and you have to say left, current, right. Then you came left, current, right. Here you came left, current, right. Then left, current, right. So there you have done the left, current, right. You came left, current, right. Then left, current, right. That means left, this one's left, this one's left, current, right. That is left, current, right. And this one's left, current, right is done. This one's left came. Now current, right, nothing. And then nothing is there. So you are just returning. So obviously it must be sorted order, right? Sorted order because that is how it works. So you must get in order traversing in the sorted order. Right. Yes, 5, 10, 20, 30, 40, 70, 80, 90, 95, 100. Right, so the final one is forced order traversing. Remember, forced order traversing, we go like left, right, current. That is our approach. Left, right, current. So again, we start with the root. Left, again left, again left, left, right, current. That is my starting one. Okay, right? Left, right, current. Then we came left, then right, left, right, current. Then left, right, done, current. Then left came, right, left, right, current. Now left, right is done, current. Then left, now we have to say right, left, right, left, then again left, right, left, right, current. Now left right is done, current. Now left came, we have to say right nothing, current. Now of course for this one left right is done, current. And now for this one left right is done, current. That must be the output. Make it beautiful. So there's a nice pattern here. Can anyone explain me? It's an IQ question. More than anything. Oh, yeah, pattern matching. Yeah, 5, 20, 5, 20, 10, 40, 30, 95, 90, 100. Yeah. So can someone explain using a common analogy, common something similar in real world, how can you explain this output to someone else? Anyone? So think about it. Remember the output is, then what output is as the piano liana pula. 5, 20, 10, 40, 30, 95, 90, 100, 80, 70. What we got then one as Uchera Dangalan Natu Oliana. 5, 20, 10, 40, 30, 95, 90, 100, 80, 70. Can someone explain it? Now, then system change කරලා දෙන්න අපිට කියලා නේද? ඔන්න system එක change කරගන්න ඉස්සර තරුණිය ඉදිරිපත් වෙන්න ඕන. තරුණිය ඉදිරිපත් වෙලා අපි ගැට ගහලා පෙන්නන්න ඕන. තරුණිය ඉදිරිපත් වෙලා software develop කරලා පෙන්නන්න ඕන. problem solve කරලා පෙන්නන්න ඕන. නැත්නම් නාකින්ට වෙන වෙන ඉන්න හැමදාම. උන්ටත් වැඩි හපන් විදියට වැඩ කරකට. challenge කරන්න ඕන. දැන් ඔයගොල්ලෝ challenge කරනවා අපිට. so අපි topi i5 නම් අපි i7. අපේ මීටරේ ඊට වැඩි හොඳ වෙන්න ඕන කියලා. නේද? එහෙම වෙන්න ඕන. අපි ඉස්කෝලේ යන කාලේ අපිට එහෙම challenge කරන්න ඉතුරු ටීචර්ස් ලා. හැබැයි ටීචර්ස් ලා අපෙන් එහෙම chance දුන්නේ නැහැ අපිට. ඒගොල්ලෝ challenge කරා. Can you explain it? It doesn't mean that you are challenging me. Just challenge yourself first. Can someone explain me using a common analogy, some sort of a practical example? How do you explain it to yourself or someone else? Maybe you can come up with a unique explanation. No one has thought about it. Now remember, we call this tree structure, right? If this is like a tree upside down, if you make it upside down, it's like this. So only thing is we draw it this way as a convention rather than this way. But if you upside down, it is actually tree. Now this is like this, right? You just keep going left, left, left. So say this is a branch. So you just cut it. Now you are here. Then you cut this. Now you are here. Then you come down here. Then you cut this. Now you are here. Then you cut this. Now you go up one side level. Then you cut this. Then you චූටි කෑලි වලට කපන්නේ දර වලට වගේ. Then you එහෙම යන්නේ නැහැ. මොකද පොඩි දර කෑලිද පොඩි දර කෑලි කපන්නේ. You go there, go there, go there. Now you cut this. Now you come one down. You cut. ඒතකොට ඔයාගේ ඉන්නේ එක්ක නැහැ හැමතිස්ස. Now you come down. මේගොල්ලෝ දෙන්න කපලානේ. Cut this. Then you අන්තිමට මේ එකේ පොඩි දර මිටි කෑලි තමයි ඔය කපලා දෙන්නේ. මාන්තෙන් මුළු ගහම අපි කියන්නේ පාහිනවා කියලා. කපලා චූටි කෝටු කෑලි ටික එකතු කරගන්න. But in a pattern. Okay, in a pattern. So that is what another way of looking at post-order traversing. Right? Now you know in-order traversing technique. Right? Pre-order traversing is little bit, maybe you can come up with a better analogy. Okay, I don't have much of an analogy for that one. Okay, right. So that's where we stop for the binary trees, because we have to do a few more things like how to delete and so on, but we don't do any coding. So then we'll look at the breadth first traversing also using stack as well. So then how to delete, there we don't do coding, just the techniques or the logic. So then we are done with binary trees. So then we'll move on to the concept called full binary tree and complete binary tree. So then we'll move on to the balanced binary tree. That is, in your syllabus, we are only interested in AVL binary tree, AVL balanced binary tree. Okay. So balanced binary tree is we don't let a binary tree grow one branch excessively. We always balance it so that it's always sort of a balance tree. Because if one branch start growing, our search and other things become slow, because it's one branch is growing means it has unnecessary number of levels. Okay, right. So we do those things next time, and we can finish binary trees next time, because I did it slowly today, because this is the first sort of a non-linear data structure you have. But don't worry, from this point onwards, we don't have any coding until we go to the binary heap. Of course, binary heap, we have another sorting technique. And we can see that the tree has two different sorting technique, one for the binary search tree, and using binary heap also, we have another sorting technique. Okay, so therefore now gradually we are moving to the sorting algorithms as well. Okay, right. So we'll take a small break. Okay, so because we want to start doing object-oriented past papers. Okay, so we'll be starting at let's just 10-minute break, because we want to do at least half-hour session and start doing some past papers. We'll be doing 2021 MCQ paper. Okay, because I always telling that we are doing MCQs and keep postponing it. Okay, right. So we'll be starting at right, and of course there can be few questions which are debatable. So sometimes that is part and parcel of the subject. Okay, and sometimes maybe we have a little bit of debates with the examiner, but that is something we can expect when you go up in the level 2, level 3, and so on. Okay, right. So let's do the first few questions. These are super easy actually. If you have done it properly. In object-oriented analysis and design, is the name given to the technique of hiding the data from users and from other objects. Of course, that is data hiding, right? Data hiding. Remember, if the data hiding is not there, you have to take something like encapsulation, okay? Because data hiding is the special case of encapsulation. It's definitely not inheritance, definitely not polymorphism, not abstraction, little bit related, but not abstraction, not specialization, which is related to inheritance. So since data hiding is not there, we can take encapsulate. So you encapsulate your data and methods into objects. Okay. So then you make your data private in that encapsulated method, encapsulated object, and expose them through methods. Okay. So therefore, from available answers, the best answer is B. Okay, best answer is B. And let's see whether is it B. Yes, B. Okay. Right. Second one. Is originally a Greek word that means the ability to make multiple forms. Right. So that is polymorphism. Right. It implies using operations in different ways depending on the intents they are operating upon. So of course, that is not a very good explanation. It is not intents they are operating upon, right? It's slightly more formal answer is there, but anyway, casually, they are talking about polymorphism, right? Second one answer is A. Yes. Third one is the concept wherein methods and or attributes defined in a class can be reused by another class. That is inheritance. That is inheritance. Because methods and attributes defined in a class can be reused, not access, and reuse. If it is access, is association. That is calling message passing. So that is inheritance. Okay. But we have to be careful. Of course, that is not encapsulation or polymorphism, but they have given generalization and specialization also. Now that is those of a sort of a tricky scenarios where now we have to read the mind of the examiner. Because generalization, specialization is also related to inheritance. Right? Concept wherein method and no attribute defined in class can be reused by another class. So that is usually reused by a special class. Right? So general class means you are going up. You generalize things, abstract things. A specialization is again reusing those things in our special case. So therefore, there's a possibility examiner might take this. So ඔන්නොතරින් තමයි අපිට ලකුණු අඩු වෙනවා නම් අඩු වෙන්නේ. ඉතින් මොකද අපේ examiners ලාගේ හිත කියවන්න බෑනේ. Maybe examiner take specialization also. Maybe examiner may take both. Or maybe examiner just take B. Of course, එහෙම උත්තර ගහන්න බෑනේ. Maybe කියලා. හරි. So therefore now you have to settle හිත හදාගෙන එකකට ගහන්න වෙනවා. So I will go for inheritance. Sometimes the examiner might take only specialization also, because these are all related things. Okay, can be reused by another class. Okay, so and if you go for a wrong answer, you get negative marks, but there are 2 wrong answers already. So therefore I'll go for at least, I like to go for all 3 also, but as a middle point, I'll go for inheritance and specialization. Because generalization is you look at it in the other way, but it is also related to inheritance. Okay. But anyway, I'll go for B and E. Okay, third one. Yeah, examiner has taken B only. Right. So because I don't know, specialization is also related to that, because in the special class, you reuse the attributes and behaviors of the general class. So therefore, still I defend my answer specialization, but the examiner has only taken the inheritance. I told you there are some multiple possibilities. So again, if I meet the examiner, I will argue why specialization is not there, because those are the part and parcel of when you go for higher studies. Okay, so that is why we have universities, right? University education is all about, we can have some arguments. Okay, but I'll go for inheritance and specialization, but the examiner has taken only inheritance. Okay, 4th one, development is developing approach that cycles through development phases from gathering requirement to delivering functionality in a working release. Again, this is a theory question, and again there can be disagreement, right, and so on. Okay, but at least we can get rid of the obvious wrong answers. Obviously waterfall is not there. There's nothing called cascade. Okay, so now you know that it's pretty much incremental, iterative. I can't remember what is V model is. Maybe something rarely used word. I'm not very sure about that. Okay, so cycles. So when we see cycles, definitely I'll go for iterative, right? Iterative. Gathering requirements, delivering functionality, working releases. So usually iterative approach is incremental as well. But I will, because I have seen this answer, examiner has taken this very straightforward answer only here. I will stick to iterative. But there's a possibility of examiner take incremental also, but let's stick to the straightforward answer only for this one. Actually, I can't remember what is V model is. Maybe something very rarely used word, or maybe just something examiner has added. You can just do a Google search for that one. Okay, I'll go for C, 4. Yes, so examiner has taken this very straightforward answer. So likewise, you can get an idea about the examiner's thinking also, because different people have different kind of attitude. Okay, right. So match the left and right columns that describes the 4 phases in unified process. Remember, inception, elaboration, construction, transition. So that is something you learn in your software engineering, right? Semester 2 software engineering. Right, so let's map it. Easier thing is read this and map this. Okay, address the known risk factors and establish and validate the system architecture. Okay, maybe elaboration. Okay, let's see, we have better explanation. A project team focus on correcting defects and modifying the system to correct previously unidentified problem. So that is pretty much transition, right? Emphasis is placed on managing resources and controlling operations to optimize cost, schedules, and quality. So it's more into the inception, okay? But there are some ambiguous answers now. Emphasis is placed on managing resources and controlling operations to optimize cost, schedule, and quality. Maybe inception, because it's more into the planning sort of a thing. Establish a shared understanding of the opportunity and the business case for producing a solution. Maybe this is inception, right? Yeah, maybe this is construction then. Okay, let's change it then. We have to, it's like a puzzle. We have to find the best out of this. Right. Establish shared understanding of the opportunity. This is more business oriented. And the business case, right? Business case is definitely inception, right? Right. So therefore, I'll match this. So now let's see whether this is going to match construction. Emphasis is placed on managing resources. Yes, we have to do that in construction. And controlling operations, yes, right? We have to do that because this is the biggest task to optimize cost, schedule, and quality. Yeah, maybe that is also okay, right? Construction means basically developing, but this talk about the management aspect of inception, construction, transition, and elaboration. So they look at those 4 phases in sort of a manager's point of view. In that case, I think that this mapping will work. Okay. But again, address the non-risk factors, establishes, validate. Yeah, maybe elaboration there. So let's see whether this answer is there. Basically, they look at the 4 phases, not from the developer's point of view, but from the point of view of a project manager. I think that's a very good question, challenging question. But anyway, let's see whether the answer is correct first. So I'll go for 1D. Okay. 1D, 2C, 2C. Okay. So then 3B and 4A. So I'll go for D. Okay. I'll go for D. That is 5th one. Yeah, examiner has also taken D. Okay. I think that's a very good question. But anyway, it's a good challenging question. Okay, because they are looking at the phases from the management point of view. Usually we look at it from developers point of view. We just incept the project. We are more into the designing and sort of thing. Right? We are now heavily in the development and little bit of design and new requirements, and we have given releases, we are doing bug fixes. That is how we traditionally look at this. But this is the management point of view. Okay. Right. 6th question. Which of the following is are correct regarding case tools? So computer-aided software engineering, we have done that. Integrated case tool, that means a lot of case tools integrated to one. So that means big integrated environment. Help all system development life cycle stages from requirement gathering to testing and documentation. That is correct, right? GitHub is a code hosting platform. Yes, and that is your general knowledge. So everyone who is in the IT field must know what is GitHub is. Version control and collaboration. Yes. The plant UML tools help blind software engineers to design and read UML diagrams. So that, of course, I don't know. Maybe they have it. And so that is, I don't know why they're asking that kind of question. Maybe just to see whether you have used it, or at least go through their website. I'm not very sure. Maybe. Otherwise, I just wonder why examiner asked this kind of a question. Okay. But maybe. Okay. I'm not very sure. Uppercase tools are tools to support code generation. Remember, we have lowercase tools, uppercase tools. So lowercase tools, if I can remember, use more in early part of system development. I don't know whether we discussed that. I think it was in your note. Right? Lowercase tool for early part of software development, uppercase tool more like testing development, lowercase tool more for modeling, right? And so on. So that is what I can remember. Let's double check the note also. But if you go by that, uppercase tool support code generation, yeah, maybe upper means usually latter part. Coding is usually latter part. Okay. Android Studio is the official ID for Android application development based on IntelliJ IDEA. I don't know whether is it a official ID, but it's based on IntelliJ. I don't know how many of you have use Android Studio, so that they ask this kind of question to see whether you are doing your own studies, right? Because these days mobile application development is a hot area, right? So therefore, those who are really interested in moving to software development area, so you must be proactively learning these things in the background. Anyway, you have those things in the mobile semester finally also, but not much coding. But anyway, I'm not very sure whether is it a official. I think that is the official ID as well, but definitely it's based on IntelliJ ID. Okay. So C may be correct, right? If this is wrong and if I mark it, I get -1. So therefore, there's a risk also, right? Remember, if this is wrong answer and if I have marked it, I lose all my marks. Okay, so that kind of things also you have to think. Okay, but of course, I think I have seen this question somewhere in the previous past paper question, and I think this may be support blind software developers. So therefore, I'll go it. But if not, maybe කලින් ආත්මෙ මතකයක් වගේ තියෙන කලින් ආත්මෙ නෙමෙයි සමහර පරණ පාස් පේපර් එකකුත් තිබුණාත් දන්නේ පාස් පේපර්ස් කරා සමහර. Right? මම හිතන්නේ ඔක හරි කියලා. Right? But in the exams, if I am not very sure, I will definitely not mark it, because if this is wrong answer, I lose all my marks. But anyway, I will go for this. I think this is correct. Okay. Anyway, let's see. Oh, D is wrong. D is wrong, not C. Right? Something else. Right? So D is wrong. That means how much I get? 0. Because this is wrong answer, it get -1. Then all my +1 loss 0. Okay, so let's double check uppercase and lowercase. It must be in your note. Must be in your note. Case tools. Computer aided system engineering. I think it is in your note. You can see, page. Yeah, uppercase tools are diagrammatic tools such as UML tools which support drawing UML diagrams. So that is usually we use it in early part of the development. Lowercase tools are tools to support code generation. So it is hard. Yes, so uppercase, yeah, I think, yeah, uppercase early part, lowercase latter part. Yeah. Okay, so this says uppercase, yeah, uppercase early part. So lowercase latter part. So I just completely swap it. Okay, so therefore, yes. So therefore, it's not uppercase tool, it is a lowercase tool. So that is unfortunately, I lose the marks because of that. Okay, so yeah, so the D is not answered. Okay, right, 7. Which of the following statement related to use case modeling is correct? Remember use case modeling? So we have to model the use cases, actors, use case, the interaction, maybe include relationships, extends relationships, actor generalization, use case generalization. You have to remember all those things. Okay. And rarely we can model even the dependency between use cases. Right. So let's see. Use case modeling is the process of modeling systems functions in terms of business events, who initiate the events, and how the system respond to those events. I think that is fair enough, right? So that is why you have the actors, who initiate the event, how the system respond to those events, how, maybe the output, okay, get the report or so on. I think it's fairly okay. But how the system respond is slightly debatable. But for the time being, let's take it. A use case model shows the functional decomposition of the system. No, right? It's not functional decomposition. But use cases are also functional. Decomposition means break it into part. In a way, that is also correct, right? Functionality is decomposed into these sub use cases. Yeah, it looks like ඔක්කොම හරි වගේ නේ. Okay, let's see. Use cases are initially defined during the requirement stage of the life cycle and will be additionally refined through the life cycle. So that is definitely yes, right? Popular in non-object oriented development environment because of its usefulness in communication with users. No, use case modeling is done in object oriented. That is why it is under object oriented analysis and design. So that is wrong. It's not non-object oriented. But the word is like, but again, this is a very tricky answer. Yes, we say use case modeling is the object oriented approach, right? That is what we learned. UML, Unified Modeling Language, use case diagrams, class diagrams, sequence diagrams, communication diagrams. So those are heavily object oriented. But this statement is again correct because though this is object oriented or UML diagram, which is more targeting for the object oriented software development, because use cases are really helpful, actually, the structured software developers also use this. Okay. Even for example, finally, software development project. So some students do it unstructured software way, especially using PHP. But still they use UML still they use use case diagrams. So therefore, in a way, it's 50-50. I don't know, popular means it's more used by this, because when we say popular, it's sort of not a very straightforward answer, but anyway, popular in non-object oriented environments because its usefulness. Because of this part, I will go for this. Because of its usefulness in communication with the user. Of course, it is more popular in object oriented, but it is still popular among the non-object oriented developers because it can be useful in communication. Therefore, I'll go for that. Okay. I'll go for that, but it can be go here and there, okay? Because little bit the wording is not very clear. A use case narrative contains all the information needed to build the structural and behavioral diagrams that follows, but it expresses the information in less formal way that is usually simpler for the user to understand. I think that is fair enough, right? We can't say all the information, but it must be sufficient information, right? Structural and behavioral diagrams. So there is little bit, yeah, maybe okay. Yeah, less formal way, but fairly formal way we represent. Yeah, simpler for use. I think that is fair enough. Again, there's a big risk here. If there is a wrong answer, I lose all my marks. So therefore, again, I want to double check, and because if it is a correct answer, I lost only 1/5. But if it is wrong answer, I lose my all marks. Okay, so therefore I will again refine it. Use this one, okay, this one, okay. This one, functional decomposition. So this is little bit deep doubt for me because I don't want to take any risk, because I prefer to take 4 out of 5 rather than getting 0. Right? This one is also a little bit doubt, but I'm pretty confident about E. A. Yeah, C, E, I'm pretty confident. These two little bit doubt, but this is more doubtful for me because functional decomposition is a word we use mostly in designing. But anyway, in a way, this is also correct also. Right. So I will not go for B because giyot pahen ekai ned. නැත්තම් තව 3 එකක් වෙනවා. So therefore I will not go for B. I will go for everything other than B. 7. Yeah. So examiner has not taken B. Okay. Because functional decomposition is, remember we discussed in software engineering, we break it like this. So that is more designing. Break it into functionalities when you are designing. So then remember we discussed about cohesion, coupling among modules. So that is for design and development. Design and development, we do the functional decomposition and then develop these components as much as possible independently. So that means cohesive and less coupling, highly cohesive and less coupling. So this is more design terminology we use, functional decomposition, than requirement analysis. But anyway, sometimes we use it in requirement analysis also. But it's more technical thing there. That is why I didn't take it. And examiner hasn't taken that also. So answer is A, C, D, E. Now, sometimes why you are losing marks is you are too greedy, right? And you are not very serious. And now these are sort of traps. You think that you did a wonderful job but these wrong answers has killed all your marks. And you ended up in something like a C minus sometimes. So therefore, very careful. I think the examiner is setting up some traps. Where the examiner take all your marks back by setting one wrong answer questions. Right? So that is what is mean by strategizing. So you must be counter attack the examiner. So you must understand the examiner and be prepared. I know you. I know your strategy. Okay. So don't take too many risks. Take calculated risks in the exams when you answer these kind of papers. Right? Which of the following is correct regarding use case modeling? An actor represents graphically as a stick figure, yes. Label with the name of the role the actor plays. Correct, right? So that is how you draw actor. An actor in use case model is placed outside the subject boundary. Yes, right? So subject boundary or the scope, outside we have the actors, right? Correct. In an extend relationship, a dashed arrow, remember we have the relationship, use case, and it extends. Extends means when this happens, this can happen optionally. And extends goes from the main use case to the extend use case. Include towards the main use case. In an extend relationship, dashed arrow is drawn from the base use case to the extension use case, correct? Arrow is towards the extension. An include relationship shows optional behavior. No, optional behaviors are extend. Include means mandatory behaviors. If the system is complex and has several subsystems, one may draw several use case model diagram. Yes, if it is complex, right, you may not be able to put all the things in single diagram. So then just a big overview use case or the system use case, and then more detailed use case for different scenarios. Okay, I'll go for that. So again, you can see, according to my answers, there's only one wrong answer. Okay. So those are the traps. You can read the mind of the examiner also, right? කපටි විදියට paper එක හදලා තියෙනවා, right? ලකුණු දෙනවා වගේ ඉඳලා දීපු ටික බෙල්ලෙන් ගහලා ගන්නවා, right? Right. So that for me, let's see whether our answers are correct first. For me, answer is other than D. Examiner has not taken C also. But anyway, I get good marks, right? So I get 4 out of 5. Okay. Why C is not an answer? C is not an answer. In an extended relationship, dash arrow is drawn from base use case to extension use case. Correct me. So why is that? Base use case to the extension use case. For me, C is the answer. I don't know why examiner has not taken C. Okay. So let's double check. I don't have to do double check. I can be pretty sure about that. From base use case towards the extension. Extension use case or how comes? Yes. Other way. Yeah, I completely miss it. In the include relation use cases, it's from base to the include. Yes. Okay, sorry for that. So it's other way. So in extend, it's from extended relationship to the base, and for include only it is other way, right? So yes, correct. Sorry for that. Okay. So in include, it is from the main use case to the included use case. Main use case to the included use case, but extends your extended use case to the base use case. Correct. Sorry. So that is my, I completely miss it. Okay. I swap it. I got the answers in the wrong order. Yeah. So therefore, yes, the answer is C is also wrong answer, right? C is also wrong answer. Right. So let's look at the ninth question. Now we have extend. Now remember in extend, so this is the optional or extended, and this is the main use case. So when B happens, optionally A can happen. Okay, so that is what is mean by extends. Right. B might or might not invoke A. B might or might not invoke A. Correct. Because when B happens, A may happen. Okay, yes. A might or might not invoke B. No, not that way. It is B that invoke A. Right? B is optional behavior to A. Yes. B always has wrong. Then it must be include. A cannot be executed without B. A cannot be executed without B. If so, you don't draw like this. So that means you must be able to execute A also. That is why you have actor called in the A. According to this use case diagram, I will say no. Because otherwise, why do you draw like this? Okay. But in general, that is the usual case. Usually B is happening when A is happening when B is happening. But because of this line, I will say no. Okay. It can be a debatable answer, but because of this line, I will say no. In that case, I will go for A and C. Right? A and C. Examiner has taken only A. Right? So that is an unfair answer. So if A cannot be directly called, why do you have a line like this? I don't know. So that I don't agree with the examiner. I told you there can be some disagreements, right? So I don't agree with the examiner, but that my agreement or disagreement doesn't matter. So I don't know why the examiner has drawn this line. Okay. But yes, I told you in general, when B happens, optionally A happen. But usually then you don't draw this line. Okay. Let's see whether they have done it in your note also. You can see. So usually we don't draw a line to this one. Then, so when you draw a line, that means your actor can call this. But so therefore, I don't agree with that answer according to that particular use case diagram. Okay. But anyway, examiner has not taken that. Right. Consider the following diagram and the statements given below. Which of the above statement is correct? B can execute. Now remember, this is actor generalization. Actor generalization. So this sector and this sector. So this is A, this is B. So that means whatever A can do, B can also do. If A can do a particular use case, B can also do it. But B may be doing some special cases. Those things A can't do. Right? So B is a special case of A. B can execute. B can execute the same use case as A. In a way, yes, but that is again the English, right? So B can execute the same use case as A. It has two meanings. So that means B can execute only the same use case as A, or B can execute the same use case as A. So again, you can see the word only is not there. So therefore, I will go for that. Again, it depends on how the examiner look at that words. Okay. B inherit all A's associations. B inherit all A's association. I don't know whether association is a good word, but anyway, sort of a yes. Okay. A can execute the same use case as B. No, that is definitely wrong, because A, some use cases B execute, definitely A cannot, because it is B's special case of A. Now again, we are in a little bit of trouble. Should I go for one? Okay, I'll go for one and say 1 and 2. Let's see if the only 2 is also there. Yes, only 2 is also there. So the answer will be either this one or that one. I'll go for C. Right? But again, this can be, it's matter of how you interpret the English. Right? So I'll go for C. That is 10th one. Okay. Yeah. So examiner has taken C. Bit of luck is also needed. Okay. Right. So the rest of the MCQs we'll do next time when you're doing. Now you have idea about the examiner, type of questions, the levels of seriousness you need. Okay. Right. We stop at this point. Right.